Good morning, folks. Today we are joined by Alexander Bokowy. He's a senior principal software engineer at Red Hat, working on things security-related and identity management. Today he'll be talking about how the next release of Fedora 39 is planning on providing basic functionality of passwordless authentication. Over to you, Alexander.
Yes, thank you. So we don't have actually anyone in the room yet because the keynote is still happening. So it will be a bit awkward. So I'm as if, oh, actually there are people coming. Great. I was about to start saying that I'm doing a remote presentation. Yeah, but the first two came in just at the beginning of the talk. So this talk is a variation on a few talks that I gave earlier this year. And I gave a talk at FOSDEM in February, and then in May at the Samba XP conference. And this is the third one, and it's a progress talk because the work is being done in the upstreams and in distributions to implement all of what I will be talking about. And that one is kind of, the things are changing. The target is also changing over time. So let me start with a bit of description. Who am I? So I'm working at Red Hat on all things related to identity management. Basically, anything around free APIs, SSD, Samba, and Kerberos, that's me or my team. I'm at Red Hat for 12 years now, so there's a lot of history in the work that I will be describing today, and in fact, we kind of going back with all of this, actually almost 35 years into 80s. And I will be talking about that one, at the progress we have today in free APA and related components, and the future. So what will happen in Fedora 39 and later, because it's still not everything is ready there. So past. If we look into the past, and past is literally like last 30 years for sure, the assumptions that we had on the operating system level were that you really have more or less compatible authentication mechanisms everywhere. So when you try to log into the system, you expect that the system actually configured the same way you expecting it to be used. So if it's not a system that uses the centralized identity management, then you have to make sure that it has all the same user databases, all the same passwords or other parts. And you really want to be able to transfer this state of authentication from one system to another. So people went a long way trying to solve this problem, and for absolute majority of them, only 2 of those survived. It's typically use of the some sort of authentication agents that store your previously authenticated kind of credentials and consult over the network. This is typical case for SSH, for example. When you do login over SSH, you kind of have a chance to use authentication agent on your original system and get access to it piped through There was recently a CVE actually in SSH, open SSH, that exploited this nature of the authentication agent by triggering a lot of literally anything into the authentication engine on your system, like on your laptop, while you're trying to log in into the remote server. So these things, security-wise, they have ups and downs, even though certain implementations exist like for decades. And a typical approach is literally you log in on your, let's say, desktop or laptop, you unlock your secrets manager, be it authentication agent for SSH or it's your desktop, like GNOME desktop, and then you use these secrets to use the authentication agent and then consume resources based on the secrets, right? There's a bunch of application-specific issues. Literally, you can choose any area, you will find problems related to that. But the most important problem is when you get to go and access resources that out of the scope of the protocol. So you want SSH agent to be used or SSH keys to be used, but you need to access file system. Go find a file system implementation like NFS or SMB or any other that actually uses SSH as your authentication method. No. So you have to use something else there. And typically it's either password or use of things like Kerberos, because Kerberos is another way of transferring your authentication state, using the mechanism of issuing service tickets and then presenting these service tickets between the applications that operate on the client side, on the server side, and so on. So it's important that in the Kerberos case, a long time ago, I think more than 30 years ago, the decision was made to actually split a state we have, the initial authentication, from the actual use of the authenticated kind of concept. So initial authentication can happen using whatever method you and your key distribution center agree with. And over years, these methods were developed in like maybe 20 years ago. So the use of smart cards became more or less standard way of passwordless, so to say, authentication in Kerberos, and that's the one used, for example, by the majority of governmental customers. That simply means you use a smart card device and you use PKCS 11 smart cards to prove your identity. ADC, to issue a ticket granting ticket that contains some information about you that you can use later to ask for service tickets to a particular services. And that one is actually a fairly good mechanism, because once you got the ticket, you present it every time you need to talk to a new service, and until this ticket is valid, you don't need to reacquire your initial kind of use your initial credentials. That builds up the idea of single sign-on, because you really signed once. Whether this signed once happens at the login screen on the desktop, or it happens, well, through some other mechanism, it's secondary. It's the part of the user experience that you build up there. But this whole thing works like fairly well. And the interesting part is that in FreeIPA and in Fedora specifically, we do have this for like almost 10 years now. If we look at the complex things that you can do with this, is what FreeIPA is doing when you enable trust to Active Directory. This is the typical authentication flow that you would see there. This is from actually RHEL documentation. And it just shows that when you're trying to log in over SSH, you get asked the password. That password, well, if there is a password need to use there, it goes into the PAM, and through the PAM stack, SSSD kind of captures this and acquires a Kerberos ticket for you, and on the login to the shell, you will get that Kerberos ticket, which you can use later. But what's happening behind is a whole machinery of different components being involved, and one of them is, actually, let me try to show here, is P11 child. That's the one that actually goes with the smart card reader, if the one exists and configured and so on. So these are typical things. You can see that this smart card reader is more or less on the client side. You don't need to get it connected to the server side and so on. But if we look into the past, actually in 2016, I gave sort of similar presentations for the enterprise desktop with GNOME and FreeIPA. Also at the FLOG, I think it was in Krakow. And we used their FreeIPA to log in into GNOME environment, and we worked with the GNOME guys to extend GNOME to support all of this. And this looked like, the whole thing looked like this. This is, I think, a VM at that point. So I'm logging in with the password, just a password, to obtain a ticket. You can see I have a ticket. This is like 2016. And then I use that ticket to come up with the VPN connection. And that VPN connection was obtained using Kerberos credentials. So you got the service ticket to my Open Connect VPN endpoint, that side. And the next step was actually using the application, which is IPA management tool, to add, since this user can use OTP, to add the YubiKey based second factor, and instead of being asked for the password, be asked for actual first factor and second factor from this YubiKey. As soon as I added that YubiKey, I can now lock the screen, and next attempt to log in will ask me for factors. So now this is not just a password. It's sort of passwordless in the sense that whatever was your password becomes your one of the factors to enter. But the same way you can do smart cards and so on. It's kind of the thing that exists in FreeIPA and in Fedora since 2015 or so. And this is a new ticket now, not the old one. You can see the, I need to stop this because this is the next one. And you can use that for a lot of stuff. So we did a bunch of integrations. We did the integration with the GNOME accounts, so that if you have this Kerberos ticket obtained through the login, whatever method was there, then GNOME accounts tracks it and renews if needed. Then GNOME browser at that point, and later Firefox, and later Chrome, all obtain the functionality to support single sign-on using Kerberos. That came in 2015, 2016, together with the Fedora and others. And yeah, that was kind of the base for all of this work. You could use this everywhere, whether it's in the at work, like enterprise, or at home. This is like enabled many people to go there. What happened, though, from that time was that we effectively stopped, we as a society, effectively stopped using the infrastructure as a driving factor for how we work. We switched from infrastructure for applications, we switched from infrastructure for people to infrastructure for applications. You don't care whether your laptop is actually enrolled into the workspace. You're most likely using some browser as to access the resources that are provided by applications on your workplace. 6-7 years ago, that wasn't true. You have to have your system enrolled, you use resources on your domain, and so on. The change came actually with the profound use of the mobile devices, and actually phones killed everything else in terms of also application development and frameworks and so on. So things became increasingly new mainframe-ish in a sense that the browser became a new sort of mainframe, ubiquitous in terms of use and access and so on. And for the authentication and most importantly authorization of the applications, people switched to OAuth 2 set of standards and framework of all these flows. And to any organizations, what happened is basically if you integrate new applications, you integrate with the OAuth. You bring your authentication into the authorization framework provided by the OAuth. And this is important part. So, okay, if my laptop is not anymore really on the network, probably not on the network that is trusted by the domains and so on, then how I do trust all of this? This whole change actually eventually went into the situation that is outlined in so-called zero trust architecture, where effectively organizations are said and being forced by the governments around the world to say that we don't trust our infrastructure anymore. We have to validate every single thing that happens there, but we also don't trust neither end user devices nor we trust our applications. So it kind of changed the game. And the idea with this is not a new one. It's basically a statement of facts. Everybody is doing that in the world, and they have to reapply at the boundary where the application is running, reapply this change of kind of see if the things are right, authorize every single access, and so on. So what we get is, yeah, really, things switch to be a browser. And this story is actually similar to what we had in 2016, except that in 2016 we dealt with environments where we had captive portals. Even today here, you have a captive portal to get on the hotel network. You have to solve this captive portal thing. And in 2016, one of the problems that we outlined was about the same. So, okay, if I want to log into my laptop with my enterprise credentials, I need to be on a network. But in order to be on a network, before I log in, I have to solve the capture portal. And I cannot solve it because, well, it's meaning running untrusted code on a system with pretty much root privileges because of how a system works. This is not Linux only problem. This problem is everywhere. So some time ago I was talking with Microsoft engineers who were implementing live.com and whatever is called now Azure or Entra ID, whatever method that they use to log into Azure and other resources. And they say they had the same issue. Running an unconfined page to log into the environment before you log into the machine is a constant pain. And to solve it, there is no real solution other than really running isolated scratched environment. They tried to provide like filtering on the level of what URIs are supported, but federation as a part of the OAuth space kills it all. So if I want to log in, let's say, to Red Hat's single sign-on system, I go to sso.redhat.com. And there I say that I want to log in with my Google stuff. So it actually forwards me to the Google page. So from the perspective of the login system, like GDM or Windows login system, now I am dealing with the content that might from the Google forward to another resource that actually handles my authentication if I never gave the credentials to Google when I created Google account. It's like there's simply not possible to solve this in a safe and sane way. So we didn't solve that problem for captive portals because that's exactly the same thing. We did not solve this yet for today's kind of login in this online services thingy. Again, I'm talking about the login to the session first and then using the browser. We don't have yet browser running in it. And the problem is really the same, how to bridge these things together. How we get there. We started with the other side. So looking into the environments, we realized that, okay, you have a browser somewhere. You really have a browser in your device. And if it's an online service that you have to authenticate with, then probably you can run it on the other device to log in here. So in FreeIPA, we implemented last year, and it's available in Fedora 37 and RHEL 8.7, I think, and later. You can instruct users to visit the OAuth to basic identity provider and authorize the access. So we did some sort of a magic, which is based on the device authorization grant flow, described in the RFC 8628, which is similar to how you authorize your TV to use your YouTube account, sign into YouTube. Here you sign into your SSH server, but really not into the server, you're signing in your Kerberos environment. Instead of doing this every time, you get the Kerberos ticket and then continue using the Kerberos ticket. So this looks like this. There's a lot of flow things happening, but I will, let me show you. I really hope it will work. Yes. So this looks like this. So I use Keycloak here as OAuth to identity provider. And this user is authenticated with the password first. So now I don't have a security key, which is the FIDO2 key associated with it. But I want to associate, so I register it. You can see I'm using the browser here on the other system. Other system, in this case, of course, these are running on the same system, but it doesn't matter. I created this key, so basically WebAuth and kind of authentication here. And I configured KeyCloak to use WebAuth and authentication if the user is there. And then when I try to SSH to the system, I get asked of this prompt that says, hey, go to this URI and confirm that you want to access this environment. And as a user, I get to log in there and use a security key to log in. Of course, the Firefox asks me to confirm whether I want to use this key, and then asks me to confirm that I want to log in into the system. So I logged into the system. I got the Kerberos key. So what happened here is I traded WebAuth and authentication somewhere at some other place into authorization to access the token, user info token on this user on that identity provider. And I used that fact as action to issue a ticket granting ticket in Kerberos. So it's starting from here, I can use Kerberos ticket for everything else I need, because this is the ticket granting ticket. I can trade it for other services. Of course, doing this every time is kind of weird. And the most weird part is, of course, I cannot do this in the login, because you see the size of the URI. I cannot really even display it in GDM. It will be cut off at the beginning. So authenticate at HTT, and then the rest will be cut off. You wouldn't see nothing basically there. So we need to do something to kind of fix this. Okay. But can we actually go and get away from the networking? Because this really wants to have this networking thing to happen. Let's see if I can do that. So this is a relatively recent demo that I made at Samba XP, where I basically took the FIDO2 token and used it to log into the GNOME environment. It still cuts off some information. Luckily, in this case, the important one is to enter a PIN and effectively ask the user to validate their presence by touching the device is what you really need, and it's shown. So it works. This is actually rawhide at that point, but you need a special version of FreeIPA, which is not in rawhide yet. It's at this point, everything is in the FreeIPA upstream already, but not released. We are going to release this maybe in a couple weeks. And so this is how I log in on this machine as well already. And it works also with the environments where you don't have networking access. The only thing that is needed is to provision a local account information that SSSD keeps in the cache about this user, but the information comes from the network, and so you need to be at least once in the network to get there. And so this is good. I get the Kerberos ticket, and that's great. It will be kind of configurable the same way we do this configuration in the rest of IPA authentication type. So you can see that you can do the OTP in the same way I did in 2016. You can do smart cards, that's PKI init, public key infrastructure use. You can do external IDP provider like I showed it in the demo before this one. Or you can use the FIDO2 based tokens, which we call passkeys intentionally because we support anything that libFIDO2 supports, and libFIDO2 plans to also support the Bluetooth-based ones and these whatever Android and iOS are supporting, but they are not supportable yet. Well, we will get there at some point. And it's also a bit complex scheme, but it's built on the same architecture we use for other stuff. So it's a Radius backend to Kerberos that simulates certain things. It just uses Radius protocol between Kerberos, KDC, and itself, but it doesn't use other Radius stuff. So it's kind of a way to extend things. We built up this, I think in 2012 or 13, to support the two-factor authentication in IPA for the Kerberos and for the rest, but it's also used for all the other stuff. And the same technology can be used also for enabling Samba AD. Well, there's dependency on MIT Kerberos, so it will not work with Heimdall. That's fine, because they don't have pluggable mechanisms for all these methods. We only have them for MIT Kerberos. And of course, right now it doesn't, but I mean, extending use of IPA infra to plug behind the Samba AD is possible, because it's just the LDAP storage of certain bits, and then the same utilities can be used to manipulate it. So that's in my plans. Again, not Red Hat, but my upstream plans to have this supported. But then another problem is what to target. So if we talk about this is not going to be supported by Microsoft. So Windows systems are out of this story. They are not going to work on anything like this. You can extend authentication packages in Windows and provide your own, but written that for certain things is a bit cumbersome, and it's really where you want to have customers, because it's a lot of work to do. So targeting Linux systems we can, and we will probably target them, given that now with the Fedora OpenQA support and the testing of Samba AD, we can actually test the whole cycle in OpenQA from the client system login and go in there. The same way for both FreeIPA and Samba AD once it's there. That's the beauty of the architecture we have in OpenQA. So for the desktop integration, the bigger kind of thing is, of course, inadequacy of the UI in this case in GDM, but it's really extended to other desktop environments as well. They are inadequate to anything but like passwords. The GDM is more advanced here because we worked together with the GNOME folks, and they cover a few other methods as well. So for the smart cards, for example, in 2019, we extended GDM to allow kind of choose which smart card to use, for which account to map into, and so on. And we kind of work now with them to design how all this extends for all of these methods, not just one, because we need to cover the login with external identity provider. We need to cover passkeys. We need to, for the passkeys, some of them, like the physically ones, they work already. So we just need to have a bit of nicer UI. But the phone-based passkeys, they will require scanning QR codes from the screen, and that means also enabling this triangle kind of connection between the different services to discover what to negotiate with and so on. So this is like, you need to have an infra. And if you want to expand this beyond just one desktop environment, it needs to be more or less independent of just one. So there's a lot of discussion ongoing. It's not, most of it not public, because in the initial steps we have to kind of collaborate tightly over the things, but some of it already can be seen in the GNOME's GitLab environment. There are some branches, there are tickets open and so on. So let me show how this looks like. This is the proof of concept. It's not a full working thing. Ray Strode, who maintains GDM, he wrote a proof of concept for both GDM side, and he wrote a special PAM module that kind of interoperates with it. It's not part of SSSD, but it's just a separate module to test the proof of concept thingy. So this is a login with the imaginary user that has actual authentication associated with some external identity provider. And when this user tries to log in, it gets to see this different dialog that says, okay, continue to initiate web login and authenticate with an external device. And when the user touches these left-right angles, arrows, then you proceed in the flow. So this kind of says, okay, you can get back and choose another authentication mechanism, or you can go forward. It's already different from what was before. It's not necessarily the final one, but we've kind of been discussing this with the UX people. So in this case, once you proceed, a request is being made, and the new authentication URL is generated, so then converted into the QR code, and then once you did all your job, you press the next button and you get login, if you're right. At this point, when you logged in, you get the Kerberos ticket issued. Okay, not in this proof of concept, of course, but in the real environment, if you run with this, you get the Kerberos ticket issued. And then, again, you can use this for the rest. In the browser, in the other applications, mounting your home directory, actually, and so on. But there are other things. There's a lot of other things. So, for example, in the real life, you often have to log in, for example, with this token. You want to log in, but you don't have a network. Okay, you can do that. But how you differentiate this case for the user to say that your single sign-on experience will not be there? Yes, you are logged in because you're allowed to log in offline, but we need to tell them, we need to pop up some information, we need to differentiate whether this was a graphical login so that this information, this warning will be a pop-up somewhere, and we need to show the message in a console if it was a SSH, for example, login, and you were unable to get the things in, and so on. So there's a lot of UX work and improvement on that one to get these things done. And then this is where the hard thing comes in. It all has to work together. It's not just one project doing their job or two projects. or 3 projects, you have to coordinate how things are delivered and appear together in the distribution. That's how we work with the Fedora. Typically, we don't advertise most of this work because, coordinating is hard enough. Promising something when every party can sleep and delay their delivery is also impossible. So in the true open source fashion, it's ready when it's done. That's how we work. We are not the only ones who are doing this. So there's a lot of parallel efforts from overall community. So there are people who are looking at how to get these passkeys information shared across different execution environments. So how to get them in Flatpaks without exposing everything. How to get these details back and forth in different places. Most of them is not using Kerberos, so not really relying on Kerberos. So we are not overlapping with anyone. We kind of getting this puzzle solved, a piece here, a piece there, and then combining these efforts together. So, for example, I know that systemd has some support for FIDO2 integration through libFIDO2. So we have some hopeful things that the definitions of these passkeys in FreeIPA could eventually be used to sign in the encryption of the disk drive and secure boot and all of these things together. At the same time, we hope, and that would be interesting to see how you can actually get this to pre-boot environment and get this booting happen. You have to cache some data that SSSD provides. You have to use it beyond this kind of network-able environments and so on. So there's a lot of work, and it's not like the thing that is the whole experience is delivered in a single release. It may well take several releases to complete all this delivery. So I know that the GNOME parts wouldn't be ready until maybe March next year, if we are happy with what we get, which I heard we are not yet. So there is still discussion across us and GNOME developers from other distributions, how to get all these things working together. But the basics are there, and I'm really excited that actually it works. So I do log in my system here with it, and I can actually show you it here as a sort of an environment. I locked the system. So this is using PAM for vlog authentication. So now I can unlock the system. It starts blinking on my device because I enabled the user verification. And I did verify it. Oh, sorry. And you probably see that my ticket is old. Oh, this is actually a different one. This is the Red Hat one. And let me switch to mine. Is this 1215? 1215 here. That's the new one. This is also, I'm not on the VPN to my home system, but this Kerberos environment uses so-called KDC proxy mechanism. So it's proxying over HTTPS to my environment, similar how we use in Fedora for Kerberos login. That's why the login works, but I'm offline in terms of IPA and SSSD environment. So that thing is is here. Let me grab. Okay, this wouldn't work because I don't have the VPN, right? Okay, let me log in there. Why don't? Is this up? So I do have now a VPN connection. I can actually run it. Yeah, so there is a passkey mapping in my IPA account for, well, this is my home setup, so it's like, and this, one of these keys there, you can see there are multiple of them registered. I'm just guinea pigging myself with all of this thing. Yeah, so this is the as far as we are, but really it's enabling you to do all this stuff. One thing I did not say is that I can now use this Kerberos ticket or any Kerberos ticket to actually authenticate not just to any other system, and that's really SSH to other system, right? But I can use this to authenticate as a part of the PAM authentication on the same machine, which makes possible things like if you have a Kerberos ticket, you can do sudo based not on the password or entering again into the authorization cycle, but with your Kerberos ticket. This is supported in Fedora and RHEL for about 2 years now. It's in the documentation. You can actually tune SSSD to specify which Kerberos ticket can be used for that. So you can say that the Kerberos ticket obtained with the passkey is the one that I'm allowed to use for raising sudo. Just password will not work. Just like anything else will not work. Only if I use FIDO2 or I use smart card. And that kind of thing is already in Fedora. I'm asking myself for a couple months now that I should write down an article about all of this, because many of these things, they exist, but they are not discoverable, right? Of course, we have this in the humongous RHEL IDM documentation, but go find things there. That's another part of the story. But yeah, this is all I have. And if you have any questions, I think we have maybe 5 minutes or so.
Thank you. Okay, so I have a few questions, so I'll try to take one question, and then if somebody wants to ask, they can ask, and then I will go back and forth. So for your first demo, when you were using the UP key and you did configure the UP key through the, I think it was free IPA, well, this is an OAuth or the token. What kind of token did it use there? Because it wasn't an FID FIDO2.
You're talking about the first demo?
Yes.
The first demo from 2016
Yes.
was using YubiKey with TOTP.
Yeah, the TOTP here was just the 6 digits, right?
Yeah.
I don't recall the exact technical term for it.
Yeah.
Okay,
that was it.
This is how it got configured, because the UP key need to have the secret for this.
Yeah, this is integrated in free APA.
It will configure the UP key and
yeah.
okay.
You can set up it with like software one, or you can set up with YubiKey and so on. The secret is actually if you don't use this special command that I had, this whatever OTP at YubiKey. If you don't use that one, it will print you a QR code and it will print you a secret there that you will use to program your YubiKey manually. But if you use that command, it will use Python bindings to the YubiKey thing to program the USB device directly. So that's kind of transparent, but you need to run that command on the device where you configure it.
Thank you.
That's kind of that is the thing that exists for like forever now.
Maybe you mentioned it. I was a little bit distracted, so I apologize in advance if it was mentioned. But is it possible to set this up standalone without a full-blown free IPA infrastructure?
So we are focusing on making this working with free APA on the first stage. The client side, meaning SSSD side, only needs to have this information in the local database, the local cache that they have. The information can be injected into the local database. They don't have utilities for that yet. There is SSS control, but it doesn't have a mode to inject this. This is on the plans. We will do that. The idea is to have a replacement for PAM UTF thingy completely, because from our experience, PAM UTF is actually a bit insecure in terms of the configuration management, and you really have to split these things. This is another part. We need to provide the user utilities to make it nicer, manageable for common folk. Right now, it's more usable for the admins who know what they do.
Excellent, and I'm looking forward to some nice blog post or documentation. That would be really helpful. Thank you.
Yeah. Okay, other questions?
I already scratched one out, so okay. So for the second demo, when we're using Keycloak with free IPA, you were using the Keycloak interface to configure or fetch a ticket that will be added for the user. As far as I understood, when you clicked on configure secret. Does this mean that the free IPA is your main ITP and then it just extended the authentication to a Kerberos server where you configure your Kerberos environment, which is the free IPA in this case?
This one is all done through the Kerberos and only in free IPA, so you cannot do this. First, you cannot do this offline because you have to communicate with both Kerberos KDC and the Kerberos KDC have to communicate with the online identity provider. So this requires Kerberos existing. You cannot configure this like standalone.
Okay, thank you.
Thank you.
Any more questions?
Thank you.
I know almost everybody in this room, but in case somebody doesn't know me, my name is Zbyszek. I work in Red Hat in the Plumbers team on systemd, and I'll be talking about stuff that happened in the last year. I submitted a version of this talk for DevConf like a month and a half ago, and I gave the talk. I think it wasn't terrible, but I also didn't get much feedback from the audience. And I asked somebody from our team, Łukasz Nykryn, I don't know, probably you know him too, and he said that, well, it was a good talk, but maybe like if you're doing large-scale infrastructure, and because I was talking about immutable images and PCRs and signatures and stuff and verification and stuff like that. And if you're an individual contributor, this is not terribly useful. So, I mean, there are usually second chances in life, but I guess in conference talks, you do get a second chance every once in a while. So this time, I will try to do better and focus on like end user features in systemd. So yeah, like if you care about the large scale stuff, this is not. I'll try to stay away from those topics this time. So a few days ago, we released systemd 254, and we try to do regular releases. Our goal is to make 6 releases a year. We average at 2.5. So there's still some room for improvement. I think we, like, compared to I don't know, 5 years ago, we increased the quality quite a bit. We do go for a bunch of RC releases, so we kind of copy the kernel workflow. We make an RC, and when the RC is made, we stop accepting major features and, well, features in general. We try to fix bugs until any known regressions in the last release have been removed. And this means that between the first RC and the final release, we block. And sometimes this takes quite a while. Occasionally, we'll just revert things if we cannot fix them. So 254 had 3 RCs, and we plan to do another release this year. Another thing that has been, I think, improving the quality and the cross-distro collaboration is point releases. So as soon as any given version is released, we create a stable branch for it and start pulling it in backports of commits. And I think we are at like 251.18 right now. And every year we make more of those point releases. We have made 29 in 2023 so far. And if we keep up this pace, there will be like 50 this year, rounding up. But most distros have switched to building from stable releases. The stable releases started out as the patch set that was used in Fedora, and then we added tags to it. And I mean, I think it's good that other distros are reusing this work and actually well, contributing to it now. And the number of open issues in GitHub, which is used by systemd upstream, is growing, well, 10% per year, or well, 12% per year. It's quite a bit, but it's also not terrible. I mean, I think that as long as the project is alive, this number will have to grow. There's just no way that we will be able to close more issues that are opened. But in Fedora, this has happened. I think this is pretty nice. So a bunch of people made an effort to clean up the queue in Fedora. David Tardon, Yu Watanabe, and other people worked on just going through the bugs, closing out some. So like approximately over the last year, we have removed, closed half of the bugs in Fedora. And especially like the RFEs where they resolved or moved upstream. I think that's good. So let me talk about some specific features. So systemd is big on synchronous operations. You request a service to be started. Systemd wants to know when the service has started bringing itself up, and wants to know when it's actually ready to serve requests. And things have been like this since the beginning. And the easiest, nicest way to implement this is with type equals notify. I mean, there are other protocols, but if you issuing of notifications using the sdnotify library or the systemd notify helper from shell scripts, or re-implementing the whole thing in your own code if you want to. It's trivial because it's just a text string that is sent over a socket. And this works nicely. We made it slightly easier to use from shell scripts in the latest release because there's a new exec option, so that notify sends a notification and then exec something, which means that like if you're doing it from a shell script, it's a bit easier. But one gap that we had was reloads. So it is traditional for Unix daemons to do a reload after getting a SIG-hub signal or another signal, but this is asynchronous. And if you wanted to do it the right way, you actually couldn't use a signal because there would be no notification going the other way. So the recommended way was to implement your own binary and make it send a signal, communicate with the daemon, do a reload, and communicate back. And this was very annoying. And we figured out just that it's actually quite easy to do it properly by sending a signal and then having the binary send a notification the other way. The problem is that this cannot be introduced in a backwards compatible fashion by default because actually the daemon needs to send a notification back. So there's a new type new type called notify reload, and systemd will send the SIG-hub on its own, but the daemon needs to send back a notification, and now we have asynchronous reloads. So in general, for backwards compatibility, all the types that have been there for services are still there, but like the recommended ways to do things have changed. So for services which don't have a startup phase but just are ready when they are started, don't use type simple, use type exec. So the difference is with type simple, systemd forks, and then one of the children does an exec. But then, as soon as the fork happens, systemd considers the service to be started. In hindsight, this is not very useful because executing of the binary might fail. And now, in type exec, the point of readiness is not the fork, but the exec that happens in the child. This is much more useful. If you use type forking, which follows the traditional Unix protocol that you do a fork and then another fork to detach from the parent. With systemd, this is all useless. Just don't do any forking or executing. Use type equals notify or type equals dbus. So if you have a dbus service, then the point of readiness is when the child acquires the dbus name. So this is the type equals dbus, or when it sends a notification, type equals notify. Or actually, you can do one better and switch over to type notify reload, because I mean, if your service supports reloads, and type one shot is well, still okay. Another kind of useful but not very well-known thing is dependency called upholds. So we have once dependencies where you start a service and this service pulls in a bunch of stuff that is needed for it to function. But this happens once at start. And then if those dependencies die, crash, or are stopped, then the wants or requires dependencies have no effect. And upholds is like a variant of this, which is effective for the lifetime of the upholding service, and the dependency will be restarted. So a classical example is where you have a container or a machine that has an, Apache HTTP service, which also requires a database to actually provide any answers. And one is not useful without the other. So you make the top level service have upholds dependencies on all the other ones that are necessary for it to function, and then, well, systemd will make its best to restart the children, the dependencies, as long as they are needed. And now it's easier to do this. There's a new .upholds directory. There's always, like, you have .once and .requires and .upholds, and you can create those symlinks in those directories at install time using the upheld by directive. And there is a bunch of new unit settings. So open file is just a kind of a convenience thing where systemd will open an arbitrary file for input or output, I mean in read mode or write mode from a service. And the nice thing is that this allows the service to be less privileged. So you can, I don't know, like if the service needs to read a certificate from a file, for example, or whatever, or write to a file in the file system somewhere, we can make the service less privileged, have the manager open the file for the service, and then the service just gets a socket, not a file descriptor. This uses the same protocol that socket activation uses. So you get a file descriptor and the file descriptor and a variable that describes the file descriptor, gives it a name, and then you can figure out what the file descriptor is for. Another kind of convenience thing is delegate subgroup. So the kernel requires that if you have a C group hierarchy, the process and part of this hierarchy is managed by is delegated to a unit, and there is a process that does the management. It cannot live in the at the top of the sub hierarchy because the kernel does not allow processes to be in non-leaf C groups. So the process would have to create a sub-hierarchy, move itself, and then do the management. This was, I mean, a bit of extra work that is not necessary. So with delegate subgroup, systemd will do this initial setup and move the process into the right subgroup. And another thing that is kind of touching on the stuff that I wasn't supposed to talk about, so extension directories. You can give a list of directories that will be used as overlays on the host file system for the service. So by specifying, just giving a name of a directory here with a bunch of files in it, you can populate the file system that is seen by the service. I mean, it's nice for, well, extending things. There are other ways to do it, but this one is like very, very convenient. In general, if like for the various, well, not those settings that I'm talking about here, but for security-related setting and sandbox security-related settings, there's always good to use systemd analyze security. In case you haven't seen how this works, systemd analyze security and the service name. Sorry for this. Is this clear? Large enough? Maybe I should do it like this. So this gives a list of settings, names, and it's adding apples, oranges, and cherries by giving some numerical score. And at the end, it says that the service is unsafe, usually. It shouldn't be taken too seriously, and of course the service could be perfectly safe. The unsafe means that it's not using the systemd features that systemd wants to advertise here. But this list is very useful to think about different ways to sandbox a service and to, it works as a checklist and a source of hints. This has been around for a few years, but still most units don't use it, and it would be really good if people were putting more sandboxing into the system. The kernel provides nice sandboxing features, and we should make use of them. Another feature that is new is soft reboot, and I wanted to make a demo of this. So I have a can I turn this off somehow? Does this work? Let's see. I have a virtual machine here, and I do a soft reboot. So with soft reboot, systemd has 3 levels of restarting the machine. You have the traditional mode where systemd shuts down all the services and reboots, goes through the firmware and the bootloader and the new kernel. We have kexec, where we load the new kernel into memory and tell the kernel, systemd shuts down all the services and then tells the kernel to execute into the new kernel, and the new kernel starts a new systemd and new set of processes. And we have now soft reboot, which works in this way that we skip all those extra steps. Systemd shuts down the whole user space, re-executes itself, and starts up the user space again. So if I do this, it's restarted, and the main benefit is speed, essentially, right? This is for the cases where you just don't need a full reboot. I wanted to show that if we look at the list of processes, and I will do this not very nice way of just looking at what I do wrong. Now. If I want everything that does not have a bracket, does this work? No, it does.
I think you need bracket dash capital E or extend the array guys.
I tried this before. Grep does not. Please help me. I want to have everything that does not match a bracket. Grep minus v. Bracket. This should work, no? Okay. So I have process 1 and a bunch of other processes. And if I do soft reboot, where did it go? If I do the same thing again, I mean, one is still there, but I get a whole new set. Sorry, I wanted to show this. I thought it would be cool. Because this also answers the question that people sometimes have, like what gets to survive, and actually pretty much everything goes away. This process itself is re-executed, so it's running new code. So this is also essentially replaced, just the number stays. Okay, and there's also a bunch of like helper thingies. So systemctl list paths does what the name suggests, lists path units. We have the same one for auto mounts. It's just a convenience thing. Actually, there's a bunch of those. They get added every a year or two, and they just list the specific unit types in a nice way. And I was talking about reboots, right? I mean, the proper way to, not reboots, reloads of services and restarts of services. The nicest way to do restarts is when you don't close the file descriptors, so that any service that connects to the sockets or pipes that your service has open does not get a refusal, but it's just delayed a bit while the service is restarting. And we have the notification protocol for it, right? You call sdnotify and you attach a socket to the notification, and you tell systemd to keep the socket for you while you are restarting. And sometimes it can be a bit hard to figure out what is going on, like which sockets are which. So there's a new thing called systemd analyze fd store, and again I will do a demo. I will do it on the laptop because systemd I want to have a nice example. It requires privileges because I don't know. Like if you were able to look at the service and see what file descriptors are stored, this would probably possibly give away too much information, so it's a privileged operation. And this is an example for login D. And you can see that, well, we have all the file descriptors, but they also have names, so that it's easier to figure out for the service what those file descriptors are doing, what they are for. And there's a bunch of settings related to this. So file descriptor store preserve allows file descriptors to not be cleaned up immediately by systemd when the service stops. So you can have like a semi-permanent thing that is kept by systemd. And this, of course, creates the problem that sometimes you want to get rid of the file descriptor, and well, there is now a command systemctl clean to get rid of those file descriptors that survive the process, the service going away. And sdnotify has additional switches to send file descriptors with a name. I messed up the rendering here. Of course, this should be a double dash. And another debugging feature is systemd analyze malloc. So again, systemd analyze. Yeah, it also requires privileges. So this works over dbus. It sends a request to a service. Get malloc info, and well, it requires privileges. And what this is just a dump from a function provided by glibc to get information about allocations. And well, the idea is that various services will implement this protocol, and allow you to, well, see what they're using memory for and so on. So, I mean, this was for the system manager, and for the user manager, there is some well, different answer. A bunch of systemd services implement the protocol now, not all. I know, it can be useful. Another one is udev admin verify. So again, a demo. When we added this, so this was implemented in this release, and when it was added, we found a bunch of bugs in our own, well, buglets, I don't know how serious they should be, in our own rules, and we fixed them all. So those are the ones from the distro that remain, and it's like, I don't know, like white space issues. I mean, like tokens that are run together. Then there's NFS that does some very strange thing because it creates a package file that is not world readable, which is a violation of the packaging guidelines. And then there is some like minor other things. We should probably get some kind of like an RPM lint script for this, but I don't know, I think it would be nice. And of course, this also finds more serious issues like syntax that is actually, that seems to be doing something but is actually not useful, for example, invalid option names and so on. And another like thing to make the use of systemd nicer is more edit verbs. So we had systemctl cut and systemctl edit on unit files for a few years. And now we have the same for machinectl and networkctl. So machinectl is the configuration files are for nspawn. So if you don't use nspawn, this is not useful for you. Networkctl is for networkd, netdev, and network files, but also for link files, which are used by udev. So this is a bit confusing. And another thing that has been changed. Let me try this. The network. Can I do edit? Does this work? I wanted to show that well, let me try this. So now I'm editing a unit file, and this is not very. I mean, this has been around for a while, but we keep improving it. So basically, you get an editor that creates an override file. So the file name is, well, I mean, without the temporary prefix is here. But to make it easier, you see the preview of the existing contents, and also, if you the cursor is opened automatically in the right place where you would edit things. So I don't know, like I'd add something and. I override something important, and well, so editing requires privileges, but of course dumping of the file does not require privileges. And I don't know, like in related, also, I don't know, this is also a symlink, so I can click on this and get this opened in an editor. Okay, so cut and edit for more files, and like another new feature or a group of features is support for better booting or better not booting of a machine when the power is low. So basically, the idea is that when we are in the initrd and before we have mounted file systems and before there is a potential to have the file systems mounted and data lost, we will do a check. So there is a systemd AC power implements a check of the battery that I mean dash low is checks that it's below 5%. Or more precisely, it checks that the system is running, has at least one battery that is discharging, and and no batteries are above 5%. So getting the check right took like, I don't know, 25 iterations, but I think we're there. Because you have batteries for which the kernel doesn't know the charge level. You have batteries which are there but are not discharging, and you have systems with no power supply, and so on, so on, so on. And there is a new systemd battery check program that runs in the initrd. It checks the battery. If it's below 5%, it says your battery is below 5%, plug in a charger, and if you don't do it in some very small amount of time, it shuts down the machine. So we will see, I mean, how it works in practice, but the idea is that this is better than booting to the system and then dying very soon after. It can be disabled on the kernel command line. And there's also a new way that we handle hibernation, because the problem with hibernation is that I mean, it's easy to, you pick a swap partition, you write the memory contents to it, and the machine shuts off. But figuring out when you boot from which of the swap partitions to read the state can be complicated. And also people use swap files, and then I mean, with partitions it's easier, with swap files it's even more complicated. So the traditional way was to put this information on the kernel command line, but this, well, this can be out of date, and then it becomes messy. So the new idea is to write information about the which swap file or swap partition was used to an FE variable. So systemd sleep creates a hibernate location variable that describes the ID of the device of the partition, and an offset and some additional details. And then when systemd is booting up, it will look for this variable and use this to well, resume from hibernation. Hopefully this will fix the problem for people who have well, I mean, for whom the previous approach didn't work. And I think I have some more time. So the last kind of thing or group of things I want to talk about is systemd repart. So this is a screenshot from systemd repart running on some machine, and systemd repart is a partitioning tool that works in this way that there is a bunch of config files that specify what partitions are expected. It goes through the config files, takes a config file, looks for the given partition. If it's there and it has the right size and so on, then nothing happens. If it's not there, it will be created or marked to be created. And if it's there, but it's, for example, too small, it will be enlarged and so on. And so repart is pretty nice, and a lot of work has gone into it in this release. It has the following features. So the partitions are created in an atomic way, which means that first repart opens the block device, uses a loopback device to get access to where a partition will be, writes the contents of that partition, or more than one. And at the very end, after everything has been written, it creates the partition table or adjusts the partition table. So either you get a partition with the file system or you don't. And also, it knows how to create partitions with a file system with contents. So knows in the sense that it just invokes the file system creation tools with in a mode where they write files to the file system that is being created. This needs to be supported by various file system creation tools, but the major ones do this. And this is very nice because, well, you get an atomic creation of a file system that is already populated. And the new part is that systemd repart now doesn't require privileges. So before it used the kernel loopback device to get access to the right place in the file, but this has the problem that if you are fully unprivileged or you're running in a container, this is not available. And now it has been, well, fixed, changed to not use a loopback device. And it has like support, primarily, in principle it supports any file system, but the ones that, for example, allow writing contents when the file system is created work better. It has also support for DM Verity and so on. And well, it's fast and idempotent. So basically, the idea is that it runs on every boot and normally it doesn't do anything, but you can add in additional drop-ins and it will create partitions. It supports minimization of the file system that is being created, which is important if you're creating file system images. And another thing that is new is that it works, a lot of work has been put into systemd repart and other systemd tools to support operating on a change your directory from the outside. This is, some of them did support that already, but not all, and I think that now pretty much all support. And this means that systemd repart can be is used for the next iteration of MKSI. So MKSI is like the systemd image creation tool. It started out as a tool to test systemd in VMs, but well, has grown into quite a useful thing. So it has like a declarative configuration that lists a set of packages, and because we added complexity to other things, so for example to repart, we were able to make MKSI simpler. So basically, MKSI had this whole understanding of partitions and how to create well, which partitions and with which size and so on, and this all has been removed. It now just has a directory where you put in a configuration for repart, and repart is called to create the partitions. So MKSI creates a temporary directory, uses DNF to or some other package manager. It also supports DNF5, in case you're wondering, to put files into this temporary directory, and then tells repart to take those contents and put them into partitions in an image file. And this is like a much different way of doing this than we did before, but I think it's, it has nice advantages. In particular, there's like this separation of concerns, and MKSI itself is much simpler. So, okay, so it has a declarative configuration like everything in systemd. It operates on package names, and this also means like you can specify anything that DNF will understand. You can, for other distributions, you can specify other specifications. So I don't know, like versions and package names with versions, or package names with version bounds. And if you want to add stuff to the image, generally the best way is to have a skeleton tree that will be just dropped into the right place. And, well, it uses other systemd tools, so it supports read-only images and signatures and DM-Verity and so on. And for reproducibility, we are still not there with full reproducibility, but at least we are making logs and manifests of what is installed into the images. And I mentioned DNF and DNF5, but the nice thing is that MKSI uses, well, can support pretty much any distribution that has like just a bunch of packages. So it supports apt, Pacman for Arch, DNF and Zipper for RPM-based distros, and it also supports Gentoo. So basically, if, for example, on Fedora, if you have Pacman and apt installed, the binaries, you can create images of any other distribution without, just it feels like native support. This is very nice. Unfortunately, this whole rework has required a huge compat break between the last release, which is like, I don't know, a year and a half old at this point, and the upcoming version. And since we're doing so many changes that we broke compatibility and the release is still delayed. One thing is that in the previous version, there was like a set of stages and it was kind of fixed. Like you build and then you install and then you test, and different people wanted different things. So this has been replaced by something called profiles, where you there's just a set of stages, and the next stage or next profile can use previous profiles. The name is a bit. It fits some of the use cases, but maybe not the others. And like I mentioned, a lot of the heavy lifting have been moved to systemd part, and this means that MKSI now it can create images without any privileges. So it works in a container. It's also faster, and another thing that we are kind of getting rid of is that before there was always this mismatch of what happens, of some things that you want to do when you're creating an image. You want to do from the outside because, for example, you want to copy configuration from the host to the image that is being created, but other things you want to do inside of the image because you want to use tools in the image, and then this also means that you have to install those tools into the image, and then maybe if the image is supposed to be very small, to remove them afterwards. So this was messy. Because we have been adding support for operating on a change root directory to all systemd tools, including repart, you can now, the idea is that everything you do in MKSI, like all the build stages, are invoked on the host, and if they want to, they will just use the change root-like operation to switch into the temporary file system. But in general, the idea is that tools implement support for operating on a change root directory themselves, and then this means that the whole thing can be simplified because you don't need to have anything installed in the image that you are creating that you don't need there. And well, that's what I have. And as always, as every project, we are looking for contributors. MKSI is in Python, so it's and systemd is in C, so we have everybody can get involved if they want to. So I don't know. Questions, please.
I have 3 questions, but I'll ask first and then pass it on for folks who have it. Right, so with the introduction of upholds dependency, there are certain services that use needs to point towards network target. So would you recommend them to use upholds and then add the network daemon to it, whichever they make use of, systemd, network D, network manager, or would you ask them to still keep using the network target?
So network target generally does not mean that the network is functional. So it's there's like a whole wiki page that explains the difference between network target and network online target and so on. I think the answer is that this is quite complicated because for services, when you start a service and it has been started, then you know it's there. But with network, you depend on external state which you don't control, and no matter what you do on the machine, you might not get network, right? So it might make sense to use upholds to keep the network configuration daemon up, but I'm actually not sure how useful that would be because let's say that you're using network manager and it crashes. You don't lose network, right? You have some DHCP lease and it will probably continue for the next day or two. So the answer is I don't know. It's complicated.
Any more questions for anyone else? All right, then I'm going to go ahead with the second one. So back like 5 years back, I wrote this systemd unit to actually mount a partition. And I didn't know that, well, that was not possible. I have to use the fstab file for that. But I saw that you mentioned of the list automounts command, and I wondered if it's possible now to automatically mount partitions on boot using systemd.
Sorry, the last sentence, because I heard if it's possible to mount partitions automatically at boot with systemd, that it has always been possible. Why not?
Okay, yeah. So, any more questions from anyone else? No? Okay, well, third question comes from me as well. So, with systemd doing bootloaders with systemd boot and cron with systemd timer and network with systemd network D, virtualization with nspawn, partition management as well, now that you mention, by when we can expect a complete world domination by systemd, you know?
Next year.
Thank you.
So with the mounts, I mean, maybe we should talk. Maybe you should give an example later, because I don't understand the question, I guess.
Oh no, I tried using the normal mount command, but I added it in a systemd unit, and that's how I tried doing it. But maybe that's not the proper way of doing it.
Oh yes. Well, so part of the answer is that so systemd had this problem where it would have a vision of which mounts should be mounted, and then if the reality disagreed with that, it would unmount things, making people very unhappy. We have mostly fixed that, I think. I mean, it's much better than it used to be. So basically, a few years ago, if you did this mount command, chances would be that systemd would actually unmount it soon after. But now it will probably just let it stay. But I mean, still, the recommended way is to use fstab. You can also create a mount unit, but there is really no benefit. It's just more lines. There's also a new setting, systemd mounts extra, I think, on the kernel command line, which allows you to specify an fstab-like line with source and destination separated by colons and options and so on. And then this will get mounted like if it was specified in fstab.
Understood. Thank you so much. Well, let's have a big round of applause for the talk.
Yeah, thank you.
Folks, the talk's about to start. Hi, we have Maxwell over here. He's going to talk about Ansible packaging in Fedora Linux and Fedora EPEL. It's not just about Ansible, but also the modules. So, good luck to you.
Need my microphone. As was said. So, oh God, yeah, can I take the handheld? Thank you.
There you go.
So Ansible is a configuration management tool used for managing servers, network devices, and other types of infrastructure. And you can also use it to manage workstations, as this one is. Okay, so what components make up the Ansible stack in Fedora? So before we had just one Ansible package that contained many things. It was a core runtime, command line interface tools, and many, many modules for all different types of applications. And recently, well, I guess a couple years ago by now, the Ansible package was split into collections. And if you'd like to hear more about the origins of this, I recommend you watch Kevin's talk from the Fedora 36 release party. Okay, so first we have Ansible Core. This is the core playbook runtime. Playbooks, as many of you will probably know, are these YAML files where you define the state of your infrastructure in this simple, easy to understand format. Ansible Core includes the runtime for playbooks, and it also includes command line interface tools such as Ansible for running ad hoc tasks, Ansible Playbook, the cornerstone for running playbooks, Ansible Galaxy, which is a package manager for Ansible content, similar to pip or npm and so on. And then there's also a lot of less commonly known tools, like one that I like called Ansible-console, which is like this little TUI interface, Ansible-config, Ansible-inventory, and so on. And then also there's the essential modules such as DNF for managing packages, and now also DNF5, and copy for copying files to remote systems, and so on. And then also we have Ansible collections. These are packaged units of Ansible content. These include roles, which are like reusable YAML playbook code, modules, which are code that's executed on remote systems. They're usually written in Python or PowerShell for Windows collection. I know I mentioned Windows at a Linux conference, what a crime. But really, they can actually be any executable file that takes in and spits out the correct JSON blob. And then also there's other types of plugins that run within the controller process, such as connection plugins. For example, there's the one that we all know and love, the SSH connection plugin. There's one for Podman containers and for Builder. And there's a lot of different cool types of plugins that run within the controller. So how are Ansible collections packaged? Upstream, we have Ansible Galaxy. Each collection has a namespace and a name. There's reasons for this due to the way it used to be tied to GitHub repositories. So this is a very popular collection, the community-general collection. As we can see here, it's here on Galaxy. You can use the Ansible-Galaxy collection install command to install it. And then we also package Ansible collections in Fedora, which is pretty unique. We're one of, I think, the only Linux distributions that does this. So we can see the community general collection transfers to Ansible-collection-community-general. And these versions are actually out of date, so I don't know what's going on with the Fedora packages site. But we can see that collections are packaged in Fedora, EPEL 9, and EPEL 8. And now we can see all these cool collections that we have packaged in Fedora. I cannot find my cursor, which is just lovely. There's plenty of different types of collections. And then most of them are named like this. Some of them are not. But we have machine-generated provides, which are consistent across all collections. And now we have 21 collections in Fedora Rawhide, 14 collections in EPEL and RHEL, because RHEL has 3 or 4 in AppStream, and 16 in EPEL 9. when I originally put together this talk, we had 9 collections in EPEL 9, which I thought was fun. But then like 2 weeks before this talk, I decided to package a bunch more collections for an infrastructure project that the Copper team was working on. So that's fun. And then we also have the Ansible community package, which is a bit of a newfangled creation. It contains a bundle of popular Ansible collections that the Ansible Community Steering Committee curates. And this was kind of meant as a replacement for the classic Ansible package, because once everything was split out, we still wanted to provide our users like a simple batteries included experience, especially for beginners and people who don't want to muck around with a bunch of collection dependencies. So we also packaged that in Fedora. And now, I don't maintain all of these packages, but I just wanted to highlight some of the other Ansible-related content that we have in Fedora. We have Ansible Lint, which is a linter for Ansible playbooks and roles. We have Molecule, which is a test tool for roles. And then Ansible Compat is a newish library that both Molecule and Ansible Lint use. We have Ansible Bender, which is used for building container images using Ansible playbooks and Builder. And I believe Upstream is looking for additional help with maintenance, so if anyone's interested. And then we also have Ara, which is a tool used for recording Ansible playbooks, and it makes them easier to understand and troubleshoot. And this provides an Ansible callback plugin, which sends your playbook data into the database, and then it's accessible via a nice Django web interface. And then we also have Vim Ansible, which provides syntax highlighting for Ansible playbooks, which I really like. And then back to collections, we have Ansible-packaging, which is a package that provides RPM macros and generators for packaging Ansible collections. Again, you came to this conference, so you must expect to hear the word packaging a lot. So now some of our macros, which I maintain along with Neil Gampa. We have Ansible collection build, which runs the Ansible-Galaxy build command to build the Ansible collection artifact tarball thingy. And then we have Ansible collection install, which is run in the install spec file section. And that runs the Ansible-Galaxy install command to install the previously built collection artifact. And it also sets up some other automation for later in the build process. And then we also have Ansible test unit, which runs the Ansible test units command. This macro should have had an S at the end, my mistake. And then this is used for running the collections unit tests. Ansible has three different types of tests, which are all orchestrated by the home-built Ansible-test commands. So there's unit tests, which are what we run within RPM builds, and then there's also integration tests, which is where you write playbooks to run your Ansible modules and then check that they work correctly within the playbook. And then we also have Ansible test sanity, which is basically linters. I wish they would change that name sanity, but oh well. And then we also have some other macros that we use during the build process. So now let's talk about generators. So the Ansible packaging generators creates the appropriate dependencies on the version of Ansible core that a collection needs. And also it can handle dependencies between collections. So for example, the AWX collection might depend on the net common collection for some of its utility code. So it would specify that in the Ansible metadata, and then our generators would pick it up and generate the appropriate dependency based on these machine-readable provides that we generate. So now this is a fun one. We're going to talk a little bit about Ansible versions. So in Fedora 39, we have Ansible Core 2.15, and we have Ansible, which is the bundle version 8. And each Ansible version depends on a specific major version of Ansible Core. You'll notice that Ansible Core does not use semantic versioning. It predates that, while Ansible, we decided to adopt semantic versioning for that. And then in Fedora 37 and 38, we have 2.14 and 7, and the community packages are supported for a much shorter time period than Ansible core versions are, so this is unfortunately already end of life. And the schedules, release schedules for Ansible and Ansible Core clash a little bit with Fedora because they tend to be released around the same time as Fedora releases. So in some releases, we've been able to integrate the newest version, while in other releases, we have not. So now we're going to talk a little bit about EPEL. We spend a lot of time maintaining Ansible and EPEL. So Ansible Core is supported by Red Hat for a small set of use cases, and it's available in the AppStream repo. And then in EPEL, we provide Ansible. So in RHEL 8.8 and 9.2, there's 2.14 and 7. And then in CentaStream, which will become 8, which will become 8.9. They have 2.15 and 8. And due to some shenanigans, which are beyond the scope of this talk, CentaStream 9 has 2.14, and it will have 2.14 for the rest of the RHEL 9 lifecycle, while CentaStream 8 will keep being updated. And now another little wrinkle that we've had for EPEL is Python versions. Ansible Core is a bit picky about what Python versions that it uses. So in RHEL, it tends to use these alternative Python stacks, which don't have as many things packaged for it and are supported for a shorter period of time. And I've been able to work with members of the Python main team to make sure that all of the macros for Python packages were able to work with these alternative Python stacks. So now, what makes Ansible packaging in Fedora special? I think it's special, at least, but I'm, of course, biased. So we provide Ansible collections as RPMs, which is something unique to Fedora. And then we also provide the Ansible bundle, so users can pick whether they want the smaller set of individual Ansible collections that they know they need, or if they want the quite large Ansible package that has everything, and they're able to mix and match because the individual standalone collections and the Ansible bundle don't conflict each other. So maybe you want some collections which are part of the bundle, and then one collection maybe isn't part of the community package, so you can install that separately. And I really like this because depending on a user's preferences, they can choose whichever path they prefer. And then another thing we do is we do a lot of cleanup on the Ansible package because it's a combination of like 100 different upstream collections, and they tend to have a lot of dot files and test files and development scripts. So we clean these up from the Fedora package. You can see some of the code we have for that in dist-git. It's a bit extensive, and we have been able to upstream some of this work, but not all of it. And then another thing we do is, given Fedora's first principle, we tend to support new Python versions before upstream does, and we work closely with them, and we backport patches as needed. And then the other thing is we're really involved in upstream. I'm a member of the Ansible Community Steering Committee, and I help co-maintain our upstream build tools. We all submit patches to Ansible Core and collections so we can participate in upstream, and also we're involved in releases and community documentation. So finally, how can you help? We're always happy to have more folks who want to maintain collections or help maintain the existing ones. I believe there's a review package hackfest tomorrow, so I'd be happy to sit down with anyone who's interested during that tomorrow. We're also always interested in helping with testing Bodhi updates, especially in EPEL, and just generally quality assurance. And then also some of the new Ansible dev tools, such as Ansible Builder and Ansible Navigator, are not yet packaged, mainly because I didn't have the time to do it, and I don't personally have a use case for it. But I would like to see these in Fedora eventually. And then also, I would be interested in getting Fedora execution environments, which is not a good name, but Ansible execution environments are containers, which are used for running Ansible playbooks, and instead of running it, just on your regular system. So I would like to get some of these set up, which use Fedora packages and Fedora container images. So I'd like to plug the Ansible packaging rooms on Matrix and IRC. We have a lot of different distributions who are involved in the package community. Kevin, David, and I are in there, and then we also have people from the CentOS configuration management SIG. We have people from Void Linux, Arch Linux, a couple different distributions, and I really enjoy collaborating with different distributions and working together with them. And then we also have the Ansible Community Room, which is where the Ansible Steering Committee meets every Wednesday, and we also have some other general discussion there. So I'd like to thank everyone for listening, and I'm happy to take any questions as best as I can. Questions? Oh, and then also here's a link to view the slides, and I'll be uploading these to the Sketch page after the talk.
If you don't have any questions, thank you so much for the talk.
everyone. Welcome. Siemanko, actually. I'm using this as my catchphrase. It's Polish howdy, something like that. So it's, well. I'm Alex Baranowski, and I would like to welcome you to my presentation about SCA and updateinfo. This is actually my first presentation in life when I have notes, because in most cases I'm making something what in Poland we will name great improvisation. And I'm quite good at it, so this is quite new for me. When it comes to my presentation, well, the slides are so basic that Microsoft called me to give them visuals. So, haha. Okay, let me introduce myself. Okay, so I'm engineer, and I would like to call myself a system engineer. I'm trying anything higher, you know, company politics and things like that. I'm working at Linux, but right now a lot of my work is connected with Polish National Center. It's Center actually, but everyone says Center for Research and Development, and it's connected with European Union funds. And we are making the open source project risk analysis. Okay, before I start, I would like to thank to everyone from Red Hat and Fedora to allow me to be here. I hope that I won't disappoint you. Spoiler alert, I might a little bit, but I hope not. Okay, about the presentation, well, we will start with very basic concepts because I like to make it that way. When we go to the updateinfo, and that it may be the poor man's SCA, then we will talk about a little bit about the supply chain. There will be also a small part about a few things that you can do actually with updateinfo. Okay, so let's get started. So yeah, there is the software composition analysis that most of people will call SCA. And it's the analysis of software and its composition. And it's like Dodge, wow, analysis, it's so smart. And the software part is very obvious. You know, it can be like remote pilot, you know, software on some kind of real-time operating system. But in kind of a composition, we can think about it on the different level. Because, for example, we can think about the dependencies. We can think about the ecosystem. Documentation repositories, mirroring system, for example, and things like that. And this is my view on SCA. And when we are making the risk analysis for open source project, we actually are doing that way. We first look into the project itself. For example, kernel is written in C, Rust, and things like that. And how it's made, if it gets through some conventions, things like that. There might be, but actually things like linters that we are using. We are looking into the code mostly. Sometimes we can make some analysis on the tests, but not like the unit test, but more for performance, things like that. If there are some kind of these things. There also might be like the, not static, but the dynamic analysis. So you have to run the software, and you have all types of checkers, profilers, tracers, or you can run some tool chains. Like Codasy or SonarQube, actually, but will give you very nice grade for the projects. When there are the dependencies, and of course, when you are making for the whole system, and a lot of open source projects, like the depths are also the projects, but they have their own grading and things like that. And each ecosystem actually manages the dependencies on its own. Some are better, some are worse. I will have the one slide actually about the NPM about it. And this is where the most of the SCA is happening, especially the security SCA. Because you have your own application, and this application had a lot of depths. Like every not true application has a lot of depths. And most of the security scanners, or whatever you will name it, will actually look if the dependencies are okay. But most of them won't even look into your application. So this is quite, in my opinion, funny, but okay. And then you have the ecosystem. And when it comes to the ecosystem, you have to think about things like the licenses. Because, for example, if you are using a GPU version 3 components, well, or if you're using any kind of license that is like the virus license. So You have a proprietary software or semi-proprietary software, and how you will manage that. And the ecosystem in many cases is not about the technical point of view. It can be about the legal. It can be about the documentation, support, and things like that. The more standard view on the SCA is that it's literally from the one paper. You can read that. It's a very short paper. I won't provide the link to, there's some kind of hub when you can read a lot of scientific papers, and you can actually get it there. And it's like technical, and they are thinking about the risk, but the integration risk, security risk, development risk, legal, and it's mostly about the licenses. Support, but if there is documentation, and if there is like real support, and management, and there's a version control. But when we think about the version control, we have to think about not like a Git, but more like the tags in Git, like this releases in that case. And this is actually a funny thing, because if you go to the SCA on Wikipedia, they are using this paper as the reference in the paragraph. And they actually are splitting the technical to the development integration, and they put the security separate. And it's also quite popular belief to do that way. OK, so this is like the SCA. Now we go to the next term, is bill of materials. And it's not it didn't come from software. This is like the patent for some ballpoint pen. And you think about it, you can take the pen from your pocket and think, wow, there's the plastic housing, for example. But you can think that, wow, this plastic housing is the ABS type, 550, that is made with this and this. When you think about the ball pen, there is this little ball. And this ball has to be made from this and this steel. There is, of course, some legend that the Chinese were able to copy this ball for a very long time because it required quite a great manufacturing process. But bomb is not everything. For example, there is a huge argue if NASA would be able to produce the Rocketdyne F1 engines that were used on the Saturn. In theory, you have the blueprints, you have like everything, but especially if there is the very quick development, there are the people who have this very specific knowledge, and they can adapt the blueprint and things they get. So the bomb is, in most cases, it's very helpful, but it might be not enough actually to create the product. And when it comes to the bomb, we have, of course, the software bill of material, and well, it comes from the normal. And let's think about it. You can say, for example, that our application need to run web server. Then you can say that it's running Apache web server, but it's different from other. And then you can say that it's running Apache 2.4.420 L8. And then you can say that we're running, and it was compiled that way with that flags and with that configure, and so on and so on. Software bill of material also allow us to establish relationship. It actually should be together. So the dependencies, how the build process work, and also shipping. And shipping should include the crypto sign. The SBOM is required for reproducibility. When it comes to the reproducibility, it's a very long topic. Of course, everyone would love to be one-to-one binary, because it's the best. Actually, if you can get like one-to-one binary, you are at home. Actually, you have Sheriff from Rocky Linux who is making the shim reviews and secure boot stuff. I also did some of this, and you need to have one-to-one reproducible binary at the end. So your SBOM must be perfect. And to do that, it's actually, it uses container to do that. OK. The next topic is CVS, CVSS, and CPE. And it's actually a little bit funny because a lot of people are talking, for example, about the CVSS. Give me the CVS score. You know, we are using the IS infrastructure and things like that. So even with abbreviation, a lot of people add some word that is in the abbreviation to just add context. So a lot of people are talking about CVS scoring and with the scoring system. So it's like obvious. And anyone who is interested a little bit in security knows that CVE has common vulnerability and exposures. And to put it very short, it's just a number, some ID that will say what kind of exposure or vulnerability it is. And it has a lot of data on it. The CVSS scoring system, there is the new version in preview right now. You can go and check it. And it's part of standard CVE. Only the very, very, very new CVEs don't have this because it might require some time to make the proper analysis. The CPE is a common platform enumeration, and in theory, the common platform enumeration, each CVE have a common platform enumeration should allow you to search if your software is vulnerable. But this is the theory, because it's a little bit complicated. And I will give you the two examples. Both are Node.js, but Node.js, when it comes to the security, is so good that it's a very good example in many places. And you have the CVE. Normally, if you have a CVE, it would like you have the A or S or whatever, or operating whatever. Then you have the organization and the project. And if you are looking for the Node.js, you will probably look for Node.js. But you have a different CPE because of a different product, because this product is bundled into the Node.js RPM package, or in most cases, any package, because it's very needed. The other one is errata for CRS. This CRS is also bundled. And you might think that, oh, I don't have all my CVEs for CPEs are OK. But no, sorry, guys. It's not that simple. Sometimes if you are using something, then you have to make like this reverse dependency build and things like that. So it's a little bit more complicated than this. OK? It's duplicate, sir. And it's even more complex because, sorry for making the small font and the point, but this part does not matter that much. Like 3 days ago, I was looking to Fedora body system. And the body system have a very nice interface. And this interface will tell you about the security update and things like that. So there was like 7 for Fedora 37. The following CVS were fixed. And there is actually the good examples, because we have the one security update that does not ship CVE. I will tell a little bit why it happened later, on the next slide, actually. We have the Zen build that is actually CVE fixed, but in internal Fedora system, when you have a CVE, it will show bugs fixed. And this one, well, they didn't have that because someone didn't click or give enough information to the system. And we have one CVE that was in triage. So everyone knows, yeah, there is something, but we have to assess it a little bit more. So there is a huge problem of CVE not found. And the Daniel Stenberg, that is the author of the main developer of CURL, that is like the most used software in the world, probably, regulatory guys, made very good article about why this is not the bad thing that the CURL have more CVEs. It's actually expected. It's a good thing. But I can say that we are part of the problems. Why? As said, I'm working right now in risk assessment project for European Union, and the scoring goes down. Someone have a CVE, scoring goes down, because you can only score if someone, provide the data. And a lot of projects actually won't provide the data. Why? Because it's easier to just fix. System D actually had like this awards for the worst vendor or something like that. There was the critical one, CVE, vulnerability, but auto root access, and there was the, big quarrel, let's name it that way. And before they get the CVE, it was over, it was fixed. It was simple fix. And in cases of many projects, you have to get this common platform enumeration before you get the exposure information. You can put it, and I get the common platform enumeration for our systems. And of course, in the end, it's like sending the simple email to that and that address, and after some time, they will add it to the database. But reading through the government documentation might be a little bit challenging. So then speaking with Elsevier, there is no reputation hit in most cases. And it's easier to maintain. Yeah, this is a big thing because I am working with a lot of clients and organizations and companies that actually sometimes don't want the update, like in most cases don't want to update the system. Everyone is overstaffed, overbooked, and things like that. So if there is no CV, they don't have to. But if there is, they're required by law to do that, to make a fix. And depending on where you live and what is the law and what is your institution doing, it might be, for example, only 30 days. And you, for example, have to ship the golden images to all your systems in a few clouds, and some of them are very legacy, and you have to update them because you are required by law to actually do that. But if vendor somehow, magically, it might happen, forget, then, well, the next update will be the next update. And there's the NDA, and it happened to one of the company. In Poland, we are making the fuszkas, so the little jobs. And one of the company, like not a ruin or something like that, but some startup from Poland actually hit that. They put the image in the marketplace of one of the cloud provider, and this image had the critical, like user critical, root access, vulnerability. And the first thing that happened, NDA. And you cannot inform your customers about it. You cannot make blog posts about update your images. No. Why? Because these images in most of these marketplaces are, before they get to the marketplace, they are review. And there's automatic review and there's manual review and things like that. And it just looks very bad for the companies. So yeah, so it's quite complicated topic when you think about it. The next thing I would like to say is that we can be only as good as the database that we are using. And there is very good paper of comparative study of vulnerabilities reporting by software composition analysis tools by some North Carolina State University researchers. I'm sorry that I didn't put the names, but I will just kill the surnames and names, so I believe that it's more respectful that way. Yeah, and the most important thing that they get there is that SCA can be only as good as the database that is underlying this software. Also, they find out that a lot of tools just believe the user dependencies. But the good ones are actually pulling them and check. Because, for example, if you are using the Python or Go or whatever, and you just want to use some framework, you can put in your Go modules or your requirements of Python, for example, Flask in Python. And you said that this is Flask, I don't know, 808. And then you install it, and you will get a lot of dependencies. And a lot of these SCA tools actually won't do that. They're very dumb. They will look into what you have, and they will just believe you. Even if you have, for example, the older version of something might pull the dependency that is vulnerable. OK, going back to Fedora RPM ecosystem. OK, when you think about it, RPM database is de facto software bill of material. The database of vulnerabilities is stored in the updateinfo files. I will have a little bit later more about the info. YUM and DNF is not trivial, as it might seem to be security scanner. And the thing that I like the most is if there is the report, there is the fix available. So it's very natural for people, and system administration, DevOps, whatever, just to use the YUM security. And when you think about it, the security package manager has a security option. Then it leverages the power of updateinfo. Updates have the categories. So do you want to enhance your system? Oh, guys, we have the bug fix. It might be interesting, but you can skip that. Or you have a security update that you might be required to install. Okay. Okay. And the security update have impact. Because if this impact is low, you might be not required to update it at all. But if it's critical, then, you know, alarm. You have to update as soon as possible. And there are links to CVEs, so you can actually read them and assess, because the new scoring system actually uses things that is called temporal metrics and environmental metrics, things like that. So the security officer in your company can say that, well, in theory, this is the critical. But in practice, after our own assessment to our environment, we know that this is low. So it's quite important that you can get this information. And there is even more goodies. You have a version locking. Yeah, I'm not fan of it, but you can do that. And that you won't get the information. You might execute some packages. Yeah, and you can get these packages from this repository and this package from this repository. And there is actually an updateinfo is something that is called restart required. I have no idea if it's working, to be honest. There is command that is restart required, but it doesn't look into it. So, yeah, in theory, there is this kind of info, but I have no idea if anyone is using it. And when you think about it, shiny new, but not better when it comes to the new way of delivering software. So yeah, snap refresh does not have security, so snaps are always refreshed. And there was proposal for it like more than a year ago, nothing. Flatpak does not have the security. There is even the dedicated website where Flatpak is bad. I won't guarantee that it's correct, okay? And up to date, but there is. And it's quite a good website because it's very short. Image is container when you think about it. So good luck with updating the container. You know, if there is like no new version, then there is nothing. And also no wide open PGP data found on most of the app images. It's like, really, guys? It's not that hard to sign something? So I made another meme that, you know, there's like no security behind. And it's important because most of system administrators want to and have to maintain the smallest update possible, because you are working not only with your organization, but you are working with vendors, for example, of application, and they say, this will work if the libc URL is this and this. And if you update it, like, and something happened, we're like, oh, sorry, guys, you have to pay us money to fix that. It looks like this. Sorry, it's true. OK, so let's go to the update info once more. It might be a little bit bigger. So it's like updates on the top level, and inside there is the update. I will go to the update, and let's go. So it's the simple XML. And in update info, this update actually look a little bit like this. I compacted it as much as I can. The important part is like you have the type. So as I said, enhancement, security, bug fixes. You have the ID. You have the severity. You have the references. This is extremely important part, references. And you have the packages list. There is the collection, but you can skip this collection. You can name it whatever you want. It doesn't matter, actually. So when you think about the references type, it can be like CVE, Bugzilla, vendor, over unknown. But if you look inside the code, it's actually managed by HowK, or HowK, I have no idea how to say the name of the library, and libsolve. And libsolve actually accepts anything. And HowK actually make these types of, so if you want to, for example, have your own type, It's quite easy. I would say that even very easy. There is the errata importance, as I said, and it can easily be mapped to the CVA because the CVA scoring has this bracket like low, medium, high, critical. There's actually none, but if there's like the CVA that is known, let me know. I never saw anything like it. So yeah, you can map it, and it's simple. There are some changes. As said before, the database is very important, so it requires effort from vendor and developers. There is no official standard. You have to look into the code. Of course, just copy Fedora, Red Hat, or whatever. It will work. There is the problem that some packages are provided, a large number of packages actually. Like Node.js is one of this example. And there's a lot of embedded. And there's also the problem with source packages. Because after the compilation, there are packages that use blobs, gems, sub-packages. So you start the compilation. For example, they will compile some Python, because they require some Python. For example, 2.7 in row 9. And after the build, it's discarded. But when you think about it, in SBOM and things like that, it should be included, because it's build dependency. So if you want to have a full SBOM and real, and to make the real analysis, you have to know that. And with gems, I get that sometimes you need some kind of rabbit gem that might be proprietary. Just for compilation, so you can discard them after. And it's illegal. But still, it's quite a gray area when it comes to the analysis. And this is my favorite one. This is the paper, not all dependencies are equal, an empirical study on production NPM. And there is funding. First one, out of 100 projects that we choose for this study, only 51 have like the production dependencies. And from this, 39, sorry. And from 39, production dependency present less than 1%. Less than 1% of dependencies. It's whoa. Yeah, wow, thank you. And why I'm saying that? Because when you think about the RPM database, and there as a scanner, RPM database is very strict. If you install something, for example, I want to install MariaDB, it will tell me which dependencies, and if I ask about what I have in my system, I will get the clear information about it. The dependencies are handled by mature software, and very explicit. In most cases, as I said, there's some build dependency and things like that. It's production use since, well, forever. Probably like row 6 or even 5, something like that, so forever. And to sum it up, yeah, like in OSCA, the updateinfo actually is as good as the underlying database. Whew. So if you will get something from this whole presentation, it's like the first point, that you can treat RPM database as SBOM. We're actually doing that. We have updateinfo as a vulnerability database, and then NF as a scanner plus updater. And it's like the full-blown SCA stack. Okay, let's talk a little bit about the supply chain. And the definition is a little bit blurry, so I will just make a few points. It's which components are used, what are the relationship between them. For example, if it's the build or shipping relationship, or if something is needed. We have that in RPM, by the way. Who committed? So, you know, how you get the source code, and much, 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 much more. And the thing that a lot of people don't know, that it must have. You have this Moscow model. I know that word Moscow is not the most popular right now, but the Moscow model is must have, should have, could have, and won't have this time. But at the moment, the SBOM are must have. There is presidential order in the US that actually will force everyone. And sorry guys, if you want to use software in US, that is the biggest market in the world, by the way, you will have to. It's not like, well, maybe we'll implement it. No, it's must have. Okay, so one of the supply chain like standard is salsa. I like it, you know, my salsa, Eminem, and things like that. I have very good like visualization of it, and it provides the build levels at the moment. And this build level, like, there is none. You can say how you are making things. So it's probably showing how package was built. There's the signed, generated, but hosted build platform, whatever the hosted build platform means, by the way. They have very good dictionary about a lot of things in Salsa, but hosted build platform is actually not one of them. And the level 3 is that this platform is hardened. And, well, I would say that I was looking into the Salsa before version 1.0. So, yeah, some time ago. And version 1.0 is a joke. It's a joke, guys, it's a joke, sorry. Why? Because concepts like source requirements, hermetic build, so reproducibility, and common requirements, discarded. It came from open source, but they made it for everyone to the point that no one will be happy with it, in my opinion at least. And the current state of Salsa also looks like an advertisement for the build platform. Sorry, we have like 4 build platforms, and the only one is one you can host yourself, and it won't get you the highest level, by the way. And some requirements like the build cannot be tempered, or the signing cannot be user-defined step. So who can define the signing? It's like, oh, I'm not user of that system, I'm not compiling here. You know, language barrier, maybe in my case, but well, for me it's a joke, sorry. The other standards that are actually used is SPDX, PsychonDX, a suite. Probably I should name it suite, something like it. And 2 of them are actually standards, also in European Union. So you can use them. There is the paper, like SBOM server from 2021. There is the small, like the source of that information. Yeah, so we can use that standard, and when it comes to the SPDX, it's actually available for some parts of Red Hat right now. It's beta, I know that, but you can get it from containers, some containers and some software, of course. Okay, the important thing that I would like you to know, that updateinfo is ready for SBOM. Because someone was smart, by the way. Because there is like it don't have to be reference, don't have to be like CVA or Bugzilla. It can be anything. Nothing stops the update info to have the reference to software bill of material. It just like, so when it comes to the RPM world, you are more than prepared. Everything is ready. But we are not producing the good SBOMs, but I will tell about it a little bit later. Okay, so what you can do with update info? We are going to the end of presentation, slowly. One of the things that you can do with update info is repreview. Before that, I have an abstract that I would like to show some new toolings that we are working on, but a thing happened, some changes for some freeloaders, or whatever you will name some companies, like one I'm working for. So yeah, I had a lot of things to do in my life during that time. Some of them pleasant, some of them known. Right now I have also a very big problem with motivation because of that. But yeah, I will provide it later, I promise. And one of the things that you can do is repo view. Scientific Linux have a repo view, it's very nice, but it's in old format. It's not suitable right now. The search engines won't actually use it. The other thing is the simple scanners. This is a very small part of one of the projects I'm doing. I cannot show it because I'm required not to show it, by the way, but we will before we ship it. So yeah, so you can have like your RPM, there's like never actualize, so it's quite the same information, and you just can list your CVS in your system. You have triggers, and this actually is something that we already have working in that project. And you make the simple query on updateinfo and simple query on the system. You save that query. You know, there's like RPM minus query all minus format name, probably some sign because, well, you might have the different vendors from with the same names and things like that. So crypto sign is actually the best when it comes to determining the packages. We manage a lot of Frankenstein systems that are part RHEL, part Oracle, part Linux, and things like that. So yeah, so we are doing that way. It can be used to rebuild images. Because normally you have to spin, for example, virtual machine or container or whatever. But it takes time. In many cases, you don't have access because the people who build the golden images for your organization may be in the different department that, for example, the security. And things like that. So they just have to give them the very simple text file. And it's especially useful for golden images, so type of images that are used across the organization or standard. Also, you can make a Rata portal. And Red Hat has very nice Rata portal. Alma have, Rocky have. So yeah, and all of them are actually using updateinfo. So yeah. And when it comes to the future and my dreams, I will provide this Rata new generation the way that we have. And sometime, as said, motivation is quite low at the moment. I would love to have the RPM tag with CPA. You know, it would be so great because then you can just ask the RPM database, then you can just some CVS search software, and you can get, you know, all the informations like this. But it's not possible because adding the tags to RPM is not that simple. Actually, RPM 5, that is not used, by the way, could have custom tags. RPM 4 does not, but maybe we can use the provides and then CPA, and this provides actually should be good enough. And the current build system, like Koji, for example, I will use Koji. I know that there's a lot of new build systems. Some of them are good, some of them are worse. Provide simple SBOM. You have this, and most of the system are including and provide installed packages. So if you are making the RPM, you have the information about the installed packages. And this is this software build material during the build process. That is also important because of this reverse dependency and things like that. And that you can have this reproducible, quite reproducible environment, build environment. So it's very important. And once more, we are already ahead of everyone because we have them. But they are not as an SBOM format that is like generally accepted. So there need to be a little bit of work done. And we are working on the new boot system. Our current boot system is used by a few companies actually. And the new one will be open sourced. And wow, I set something on fire actually. Because our boot system was always source RPM based. We never used the dist, git, or anything like that. And we always provide the batches. So we have customers who are rebuilding some systems. And we just give them batches, and we're making that public. Well, 15 minutes, actually. It would take 15 minutes to clone. The longest part will be that you will need a logo for your new system. So yeah. And this is my dreams, and this one is actually founded. We have a founding in our current grant because we need to create a new build system, by the way, because we need the SBOMs, so proper SBOMs to the risk analysis. So we have to create the new build system. None of them was good enough. Yeah, So that's like my future ideas, dreams. Sorry once more that I didn't provide something that I should, but the world is on fire. So yeah. So it was quite hard to make anything else for me. Okay, this is the end. Any questions? I would really love to answer any question that you have. So, how do I use it?
Hi. How do I use it, assuming I'm on Alma Linux?
What?
How do I use updateinfo?
Oh, okay. So every time when you are asking, for example, Alma, you said, when you are asking the repository about the repository, it actually looks like this URL, and the UM or DNF will add the /repo data /repo MD, that is metadata. This is like XML file. And update info is one of the entries in that XML file. Then the UM or DNF and ripsolve and ripok and whatever, this whole stack will actually pull that update info for you. It will be probably compressed, it will decompress it, read it, parse it, things like that, all the magic. And then it will just print you, if you have a security update in your system. It can be used that way. It can be used, the most of the admins that I know actually use just DNF minus or minus security. You can also set the level that is required, or you can get the security and then info, so you can, before you update, you can get this information about the CVEs and things like that. So, and it's all like very natural for organizations.
Thank you.
Thank you. Okay, so okay, thank you very much for coming, and yeah.
Awesome, thank you everyone. Since we've ended a little bit early, the next talk that's in this room has been canceled, so there are other talks going on in other rooms. I'd be remiss if I didn't remind everyone, if you haven't already gotten your badge for Flock, there is a QR code in the back of the room. And then we'll be picking up back here after the coffee break here in a little bit. So thank you all very much. Welcome back, everyone, to the Fedora Leads in Linux Distribution Development track. And we're here today with Lukas Ruzicka for a talk on auto testing in Fedora. So I'll hand it over to you.
Hello, my name is Lukas, and I work for Fedora Quality Engineering. And today I would like to give you a step-by-step guidance on how to set up OpenQA. I'm not going to go over the concept much deeply because yesterday this was done by Adam already. So those who were interested in it basically know that OpenQA is an automated test tool. Originally it was developed by SUSE. It still is developed by SUSE, but Adam also adds some patches into it, so Fedora also has some part of it now. And it allows to test various features of operating system using the hands-on approach, like as if a user would do it. It basically creates and runs a virtual machine, loads it either from an ISO file and a QCOW2 image, and it then performs various actions inside the virtual machine, compares the expectations to the real state, and evaluates the outcomes. The OpenQA architecture is basically that there is a controller that does the scheduling stuff and the web UI and job handling and communicates with the database, and then there is a worker, or there are multiple workers that do the actual testing. So you can have many workers, you can just have one worker, it depends. For the local installation that we are going to talk about, we are going to use one worker because I think it's enough to consume a lot of our memory. So first, we need to install OpenQA. That's a fairly straightforward process because everything is packaged in Fedora. So basically, we use DNF to install the whole stack. And especially the packages like OpenQA, OpenQA HTTPD, OpenQA Worker, Python 3 JSON scheme, and Fedora messaging if you want to consume the Fedora messages. But if you don't, you can omit the Fedora messaging package. So to start with, the DNF install OpenQA, OpenQA HTTPD, and the rest of the packages is a good start. And this will install the whole stack. So you will need like 2 minutes to do it, for example, which gives us 18 minutes left. Now, when everything is installed, we need to configure the HTTPD server. That's very simple too, because basically there are template files, template configuration files provided by the OpenQA packages. So we only navigate to etc httpd conf.d directory and then copy the OpenQA conf template into openqa.conf, and we copy the OpenQA ssl.conf template into the OpenQA ssl.conf, and we enable the HTTPD CAN network connect for SE Linux and restart the HTTPD. Now basically that's the first part. There were times, maybe 2 years back, when the SE Linux cooperation was not that great, so it was recommended to switch SE Linux to the permissive mode, but this is not longer required. So you can operate on enforcing mode quite safely and without any issues. Then we need to configure the web UI. The configuration resides in the etc openqa openqa.ini file. And basically, we need to do two settings to the file. Under the global chapter, we find, or global section, we find the branding, which Fedora recommends to set to plain. The other option being SUSE, I believe. And if you wanted the nice chameleon, you can use the SUSE branding. Otherwise, it's totally the same. Just there is the quite nice logo of the chameleon. And the download domains are fedoraproject.org. The authentication can have multiple modes, but for the local instance, the fake authentication is good enough, which basically creates a demo user, and you will control the web UI using the demo account. Normally, on OpenQA production, there is the OpenID authentication, so you can use your FAS account to control the web UI if you have the rights and if you have the permissions to do so. But for this local instance, we are not going to need it. Then we will install and configure our database. So DNF install PostgreSQL server, and let's initiate the database with the PostgreSQL setup initdb command. And that's basically it. Now, OpenQA is ready to be run. And you can see that there is a procedure of several services that you should start. And you have two options, basically. Either you enable them and you make them start all the time. But because I don't want OpenQA to run all the time on my computer, so I usually start them with a script. And I believe they should be started in this order. Actually, I didn't start any other order. I always followed the guidance we have on the wiki page. So first you start the Postgre, then HTTPD, OpenQA GRUE, OpenQA Scheduler, OpenQA WebSockets, and OpenQA Web UI. This is enough for the Web UI to start and to make further settings, but at this moment, we are not able to do any testing yet. So let me start the OpenQA for you. It's now installed. I am using the start openqa.sh script, which basically starts it in that order. And now you were able to see that it's unable to connect because the server wasn't running. But now when I hit F5, it still is not running. How come? I don't want to debug that now.
Welcome to live Enable the Wi-Fi now? It shouldn't need the Wi-Fi.
So.
Well, I see HTTPS in the URL. Is it okay?
Let me, it might not, I don't know.
No, it shouldn't be.
Oh, yeah, it shouldn't be. Great. So now you can see that OpenQA is running. That's the web UI. Now, yeah, it says HTTP localhost, yeah. So you go there, open it, you see the web UI, and you click login, and that would immediately switch to logged in as demo, right? And now you find manage API keys, and I don't want to show you my API keys, so I'll switch to the presentation here. And manage API keys. You click create to create the new keys, and you copy the key and the secret to some files I'm going to show you in a moment. There is the expiration mark or radio button that you can check or uncheck. So I didn't know about it, or I didn't pay attention to it first, and I was pretty much surprised after a year, because the expiration usually is 1 year. So after 1 year, I was quite surprised that it didn't want to start the tests, and it claimed about there is no API, and I was like, well, why? What's that? And then I realized that the key has expired. So for a normal use, you could create a infinite API key that will never expire if you uncheck the expiration radio button. And then you added the etc openqa client.conf, and under the localhost section, you copy the key and the secret. The secret is the second part of the key. It's quite visible in the web UI. And that's it. We have installed and set up OpenQA to work. And when we start the worker, systemctl start OpenQA worker at 1. So this will start the first worker and connect it to the OpenQA. And now we are ready to run the actual tests. And this can be done in 15 minutes if your network isn't extremely slow. So, which gives us 5 more minutes. And that's downloading the tests.
So if I dial-up, how long would it take?
Pardon?
If I dial-up.
If you have a dial-up.
Yeah, what if I'm downloading this through dial-up? How long would it take?
I don't think it's going to take you very much time installing OpenQA, but it's going to take you some big time downloading the tests.
Would you say I'd be able to finish college?
Between you download the tests and start it. From my experience, the problem is I don't know how dial-up connections work nowadays, but a year ago I have the LTE connection back at home, and it wasn't the fastest connection in the world. I got problems with downloading the test repository because it has, I think, 14 gigabytes, I think.
Is it that much?
Yeah.
Jeez.
And
Okay,
the LTE connection would have dropouts occasionally, so Git would complain about them, and it stopped working. So this was a problematic thing to download, and once I had to head to the Red Hat office to download the repository. I know that you can use the Git depth one, and you only download something, but it still is quite much because of the needles, and we are going to see what the needles are.
So, I'd say my 56K modem is not going to be downloading it anytime soon.
No, it's and to run any tests, you have to download an ISO as well. So,
Crap.
Actually, you don't need to download the tests to work with OpenQA, but in this talk, I am assuming that you can. Because, I will tell you a little bit later. So basically, you go to a Packer repository, and you download the test into var lib OpenQA tests. Then you do the repository git clone. You clone it as Fedora, and you change the ownership to GeekoTest. GeekoTest is the OpenQA user, and so that it has rights and permissions in those OpenQA test directories, it's needed to give it the permissions. And then we have the tests. We have the tests, you can see it on the right-hand side. But the tests are not loaded into OpenQA yet. So we will do it with the FifLoader tool. And you can see that there are templates.fif.json and templates updates.fif.json, which tell OpenQA a couple of informations. It will give OpenQA informations about the available machines, about the available products, and about the available profiles, and about the test suites that it can run it. And you load it with the FifLoader Pi application. It's a tool written by Adam, and it works wonderful, I must say, because before we had this, the tests and the machines and the profiles had to be defined by YAML file or in YAML files through the web UI. And when you made a slightest mistake in the YAML file, it would complain and never work. And this FifLoader changes the game totally, and now it's very easy, because if you need to add, well, from the user's perspective, it's very easy actually. Because if you need to add another test, so you can just take a look how the test is defined, and you copy the JSON section, and then that's it, right? Basically. So you load it, the /c means clean all, and the -c means clear all, and -l means load templates.fif.json. This will give you the basic Fedora tests. If you want to load updates testing, then you use the second template with updates. And that's it. 20 minutes and everything is set up and ready. So just some explanations. We will work with machines, tests group, images, jobs, test suites, test, and needles. So a machine is a QEMU-based virtual machine, basically. There can be different, but we are not using anything else, just the QEMU-based virtual machines. And you can set it in the machines section of the template file. So for example, the UFI x86 _64 is defined like this. So the architecture is 64-bit, the partition table type is GPT, QEMU CPU, number of CPUs, RAM, the VGA driver, and so on. UFI is 1, which means true in Perl. So you also have the pflash codes and pflash vars to define the proper QEMU virtual machine here in this machine section. You don't need to define anything else unless you need something very specific. Normally you would just use one of the available, which is either a BIOS or the UFI machine. A product is something, it's like a group of tests that run in the scope of the Fedora flavor. And it can be, for example, workstation, server, or everything, and then you put tests inside of these groups. So when you run the workstation, then it runs all the tests that are scheduled for the workstation, and it doesn't run the tests scheduled for server, and so on. And you can define this in the product section of the template file. So for example, the Fedora Workstation Live product is defined as this. So the distribution is Fedora, which is the entire thing. The flavor's name is Workstation Live ISO, and then you have settings with variables telling the system that the desktop should be GNOME, that it should use the install default upload test to actually create the installed Fedora image. The HDD size should be 20 gigabytes. It should run out of the live. The package set is default and the test target is ISO. These are, however, user-made variables. So you can use them in the tests. If your tests should be structured without those variables, you don't need to define them. But our tests are structured around them, so we make differences in them according to the desktop types, or for KDE, some specifics are used, and for GNOME too. So we usually have one test that can have various branches depending on what we need. So some branches switch on for KDE and some other branches switch on for GNOME. This is how a profile is defined in a profile section. And this basically tells us that the product Fedora Workstation Live ISO should run on a 64-bit machine, which is not UEFI. The 64-bit is a BIOS machine. So these chunks are taken from the code. So this is exactly how you do it. And then you could define your own profile telling OpenQA that your section should run on a specific machine. And then there are test suites, and they define how a test or a group of tests will run, and it allows you to set the test variables to control the tests. So basically, you can use the variables that are defined in the machine. You can also use the variables that are defined in the product, and you can also use the variables that are defined in the test suite. And I believe the later you define the variables, then the more valid are they. So if you have the variable which has the same name and a different value, so the test suite value would override the machine value. Yeah?
Yeah, you can override that by prepending the variable name with a plus. It got very complicated because over time we've realized we need to sort of do things in different orders, but more or less, yeah, there's an inheritance.
Normally also it's good to mention that on the production the variables are pre-filled by the OpenQA scheduler and by Fedora messages that are coming into it. When you run the tests locally, some of the variables are not pre-filled, so the test might break, so then you need to fill in the variables, and we do it on the API CLI command. That's the best bet, I think, because you don't need to update the templates. So what this means, basically, that there is a desktop terminal test that runs for Fedora Workstation Live on x86 and PPC64, and that it boots from the hard drive being the disk, some flavor and machine variables .qcow2. The flavor and machine will depend on those variables being set in the machine, for example, or in the other test that runs before, because let me show you the install default upload, the deploy upload test called install default upload will basically install Fedora and upload the installed image to the OpenQA, and then this would start after the test, deploy upload test, so after install default upload, and it would use the image created by the install default upload. And now the post install variable says just take the desktop terminal and run it. There are several ways how it could be done, but when there is a test that should follow the installation of the image, then the post install variable is the cleanest way to do, I think. A needle is how OpenQA would recognize what is expected. We need to tell OpenQA what we want to do. So we define needles. Needles are PNG images with defined areas. So I decide some portion of the PNG, and OpenQA will look at it, and it will try to compare it with what it sees inside of the running virtual machine. And if it finds it, it will do something about it. It might click on it, or it might just check that something like that is there. And if it is, then this tiny little test will be passed. And if it doesn't see it, it will complain and it will fail. So you can, for example, check that there is a nice Fedora logo in the upper left corner using OpenQA by defining a needle with that logo. And basically, the needle is two files. It's the PNG file with a screenshot. There is a mistake here on the slides. It should be a PNG file with a screenshot and a JSON file with the area definition plus some other info. Each needle consists of two informations, the area description and the list of tags, and it looks like this. So you can see that the tag is events about shown, which controls that the about window of the events application has been shown on the screen, and the specimen picture will be taken from the events about shown.png, and it would start on X position 445 and Y position 286. The area will be 133 pixels wide and 146 pixels high. So this is like something like a square almost. And the type of the needle is match. Match means visual comparison. And that's what works. Sometimes, or I have read in the documentation about the OCR needles, but mythical OCR needles that I was told during vlog that they work, and that somebody on SUSE actually tests Battle of Westneth using the OCR needles, but it seems that the code needed to run it is still not merged, so you need to patch the OpenQA, and I haven't had time to test it yet. When you want to write the test of your own, you don't have to. Now you understand everything and you can locally run all the Fedora testing stuff. But if you want to write a test, That's a Perl script that defines what you do inside of the virtual machine and what you want to expect. So you basically define some mouse actions, some keyboard actions, some checks and evaluations, and you can also evaluate script outcomes. So basically, you can test some graphical user interfaces, but you can also test some CLI commands, and all that will work. And tests have various statuses, such as passed, failed, soft failed, running, and so on. If you want to create the test, you need to create a Perl module, put it in the tests directory of the OpenQA directory that we have created, having cloned the repository, and you should use the libraries in the lib directory. You don't have to, but it's there, it's been already created, it's been already programmed. You don't want to reinvent the wheel, so you can check what commands the Fedora has made for you, and you can use it. For example, if you want to do some login, you can log into a console as a root, for example, so you don't need to program all the stuff and all the typing and all the checking, but you simply use the login to console and something like that, or log into the graphical session, and it's in the library, so you can just take it and use it in your tests. And then you should probably study the test API, which is the description of the commands at open.qa API/test API. Then each of the tests should have a test header, which basically is what libraries or what other packages it uses. So this will tell me that as a base, the installed test is used. Strict is the Perl thing, which keeps looking that your code is correct and that you don't do dirty stuff with it, because normally Perl doesn't check, for example, for how do you say that? Yeah, if you define a variable, so the namespace should be limited to a subroutine, for example, or to the entire package, and Perl normally doesn't check for it.
Does it only support Perl or other languages as well?
The tests should be written, are written in Perl. The whole thing is programmed in Perl, but apparently, according to the documentation, the tests could also be written in Python.
Lovely.
But I have never tried.
Using Perl makes it dirty by default, doesn't it?
Pardon?
Using Perl makes it dirty by default.
I don't know.
Yes, but the alternative is to go write your own. I don't know if Perl would have been our first choice, but the other alternative is to go and write our own whole thing. And I don't know. Perl couldn't possibly be that bad than having to go write your own framework from scratch. And Adam will know more.
Yeah, just quickly, they have this crazy translation layer upstream, which I don't remember the details of how it works, but it uses some fairly janky stuff, and you can write a test in Python. And some team internally at Red Hat, I initially turned this off because I thought it was so hideous, but some internal team at Red Hat asked me to turn it back on, so it's now on in the Fedora packages. I haven't tried it myself, but it should work. Using Perl to write tests is not that terrible, because tests tend to use the functions from these libraries that are very, very simple functions and quite well written. So most tests just tend to be strings of type this, assert this screen, then type this, then assert screen, and it's very kind of formalized. So you're not writing ugly Perl most of the time. There are a few cases where you write ugly Perl, but yeah. Yeah, so for these tests, a lot of the tests, it's fairly simple, so it's fairly readable. Yeah.
Yes, Tim?
You can write good Perl. It is possible. It's just, it doesn't care if it's readable or not, so it all depends on the person reading it. So the tests that they're talking about should be reasonably legible.
For me, for example, doing this, I saw Perl for the first time, but I somehow got used to it now, and it's okay. But the truth is that sometimes we fight over readability with Adam, because he is better at Perl than me, so he thinks it's super readable, and I think like maybe not.
Well, if you work in the sewer every day, you get used to it eventually.
Yeah. So basically, if you use strict, it doesn't let you do variable definitions with wrong namespaces, for example. Then use test-API is that you should use the built-in functions, and use utils means that you use the basic Fedora library where most of the pre-programmed Fedora routines are placed. So test-API is the total basic. If you don't use test-API, you will not test anything. And if you don't use utils, you will need to do a lot of typing. Then the test file should have a subroutine called run. So this is basically a function where everything what you want to test is put. Anything else what's outside of the scope of the subroutine run will only be valid inside of the test package. And then you add another subroutine, test flags, where you can define what to expect, what will it do after the test finishes, what will it do when the test fails, or if you want it to fail, because, for example, the fatal flag will tell that if the test fails, then the whole test suite fails. But if you don't want it, because you have other tests inside of the test suite that do not depend on the first one, you don't want to make it fatal, then you can ignore the failure, and that means that it will ignore it and continue. Sorry. You can set the test as a milestone, which means that after the test finishes, the state of the art of the virtual machine will be uploaded to OpenQA again, and then the subsequent tests will be starting off that milestone. So this is, for example, useful. Okay, thank you. This is, for example, useful when you want to test an application and you don't want to do starting it all the time, but you would like to take all the subsequent tests from a clean application. So we start the application. Once it's running, we will upload the state of the art to OpenQA, making it a milestone. And then we, for example, create a new file. And then I don't care what happens next, because the next subsequent test will return to the milestone and again will start with a clean started application. So sometimes that's good, for example, when a test fails and the subsequent test would expect something what's not there because the previous test has failed. So I can fight it with this rollback. And always rollback means return to the milestone. When you don't set any flags, then everything will be 0, I believe. And maybe fatal will be.
If you don't set any flags, I believe it will roll. If you don't set any flags, I believe it will roll back if a previous test module fails. But it won't die because fatal's default is 0, I think.
Yeah. I always use at least one flag so that I know that what it should do, basically. And there is a test example for desktop printing, so it looks like that, but I'm going to show you another test. These are the libraries that currently are available. So it probably is self-explanatory, like modularity.pm would be functions that we use when testing modularity. Fedora distribution will be functions specific to Fedora. Cockpit or Bugzilla, you know, it's you can expect what's in there. What makes a library if you want to create one? It's another Perl package that starts with the package keyword. Then you give it the name, like for example, package desktop tools. And you use the base exporter and the use exporter, and then you export the variables using, for example, our export is start GNOME software and install application. This will enable the subroutines in this package to be used very easily without having to call anything else in the test files. Without exporting it, you would have to call that like desktop tools ::, and then star GNOME software, which is not very convenient. So it's good to export those functions. And now let's take a look how we can create a calculator test, a very simple application test for a calculator. The test will be placed in the tests directory of the repository files or the repository directory, and we can start, for example, by touching it. And before we start to write it, we can register the tests in the templates to make sure it will run in OpenQA, because normally without the registration in the templates it would not work, it would not start. Bad thing Sumantro is not here, because he's going to need this. Hopefully he will see the recording. Okay, so the test must be registered in the templates, and you want to give it the architecture, the product, and the variables. So basically, you need to add a section to the test suites section that has the name of the test, calculator. You will give it the profile where it should run. So this would run on Workstation Live ISO 64-bit machine. So it won't run on the UEFI machines, just the BIOS machine. And it will take the pre-installed ISO, it will run the calculator test, and it will run it from the disk flavor machine QCOW2. Whenever you make a change to the template file, you need to reload it to OpenQA. So you do the fifloader -c-l templates.fif.json. And when we want to run this test from a pre-installed image, which is also possible, we can replace some variables and say that the HDD1 is not something generic, but it's a specific one. It's the workstation.qcow2, and the user login is test, and the user password is weak password. And now I am loading the tests using the entry point system, which allows me to put a list of tests that I want to run. And so I can start with graphical weight login test, which logs me into the system, into the GNOME session, and then it runs calculator test. And again, I need to load it using the fifloader. So the basic syntax of the test file is this. We have talked about it. There is one more thing I wanted to stress to you, that each test module must end with the 1, because each Perl module must return a true value, which is defined here on the line with 1. If you don't do it, it will complain and it will not run. And it's problematic, and it bit me a couple of times in the beginning. So don't forget about the 1. And then you can create a subroutine that will only be valid for the test itself. For example, you want to repeat something a couple of times and you don't want to repeat yourselves. So you can define sub-delete result, for example, and say that this delete result subroutine will always press the escape key when called. So such a simple one, right? But then you can use delete result instead of send key escape. And if this is more complicated, then you can save some time typing the stuff all again and all again. You could theoretically take this subroutine and place it into a library if it makes sense to you. And then we want to start the application. So in GNOME, normally we can hit the super key, and we do it with send key super. We type string calculator. The max interval 10 makes it type a little bit slow. In Fedora, you can find a wrapper for typing strings that is type safely or type very safely, but I'm not using it here because I wanted to make it as generic as possible using just the test API commands. So the max interval makes the typing a little bit slower so that the GUI has time to respond, and the texts are really what they should be, because if you type too quickly, sometimes letters are gone and then the texts are incorrect, and basically the tests fail because of that, of the typos that are made with the engine. Then we send the enter key and we check that the calculator has started. Assert screen means check that we see this particular thing in the screen. Then it's merely some clicking. Assert and click would mean that it checks that the needle is there, that there is the widget that we want, and if it's there, it clicks on it. You can add the button parameter to the command, and you can define whether the button should be left, right, or middle. If you don't do anything, it's left. So normal clicking is assert and click. Also, by default, the OpenQA will wait 30 seconds until the widget appears. So if you think that it should be there in 10 seconds and you want to specifically check that it starts in 10 seconds, then you could define a timeout parameter and you could make the timeout to be 10 seconds. If you leave it out, it's 30 seconds. For some tasks, you might need longer, so you can make it longer. Timeout 60 seconds, 120 seconds. For some installation purposes, it's maybe 400 seconds.
Oh no, we've got like 3,000.
Oh, yeah, of course. For uploading tests, yeah, this is quite long. So basically, click on button 5, click on button add, click on button 7, click on button equals, and check that the result has been shown. So that's one part of the test. Then we can multiply two numbers, but no clicking, just using keyboard. So we will type the string 12 times 15, max interval 10. We hit return or enter, and we check that the result has been shown. We delete it again, and then we can switch to the keyboard mode using the Ctrl-Alt-K combo, sending the escape key, typing a complicated string with brackets that should basically be very clever about what to calculate first, you know, and we hit enter and check that the result has been shown again. And that's it. We have the test now. We have registered it, so we can start it.
Well, you have to take the screenshots first. Oh, are you going to do
Oh,
that?
yeah, I'm going to do it in it. So OpenQA Web UI now will show us everything about the tests, but it can't be used to start the tests actually, or at least I don't know how. So you are using a OpenQA CLI command to make an API call to the OpenQA server, and basically it looks like OpenQA CLI API /x post ISOs or ISOs, and you use the file.iso, which is the ISO that you want to install.
Yeah, just quickly to make this part a bit less scary possibly, there's a slightly higher level runner you can use if you're okay running on official Fedora images called Fedora-OpenQA, which is the same thing the official scheduler uses. And with that, you can use it to just say, hey, schedule on this image from this compose, and it will do everything for you. But the trade-off is that it can only schedule for official Fedora images, and it will need to download the image. So I think Lucas doesn't use that because it would take a long time to download the image on his system. So he's using a lower level interface to make it faster.
I am using this because I found it in the documentation. The first time I was trying to run the tests, and I used to it, of course, and then I keep those commands in a file, so I just uncomment the one I need and run it. So you can pass variables also using this command. Some of them must be passed, like distri, version, flavor, arch, and build. Subvariant, desktop, and development are good for installation tests. So if you have a pre-installed image, it's not that important. But if you want the test to install it, so it must know whether it's installing rawhide, if it's being developed, because the development, for example, checks that there are some parts present during the installation, like the pre-installation warning or pre-release warning, and if it's not there, so it pretends that no pre-release warning is shown, but the pre-release warning is shown, and then the test fails. So these variables should be passed, and then it is being scheduled, and you can see it on the all tests page. So I will. You can also see the tests that have already run, whether they passed, which is green, whether they soft failed, which is yellow, or whether they failed, which is red. And you can click on the dot to explicitly see the details of the tests, and then you, for example, see that this is probably from it looks like the KDE start-stop test suite. So the ABRT started with some hiccup, aggregator started and finished okay, and so on. Test needle. When you click on the icon of the image, you will see the screen that was recorded, and you will be able to see the area that was compared, and if it is green, it was found, and candidate needles and tags tells you this was 100% Kmail, runs, and some number, which means this image from the virtual machine resembled 100% what we expected, so that's fine. Normally, if you don't do anything, so by default, it tolerates 4%, so when 96% is still there, so the needle is taken as passed. If it's less than 96%, the needle is considered not found. And you can, of course, lower the bar a little bit and make it 90%, or you could set it higher. It depends what you need. And if there is an error, it's marked in red, and there is basically 2 red fields for every error, and mostly the error in one test, there is just one error because then the test finishes. So, but there are 2 places, 2 screens. The first one is showing you where the needle was expected and not found, and the next one gives you some information. That information is a generic one for like this, test died, no candidate needle, and sometimes you could define your own strings, so you could basically get quite a nice information about what happened in the test. And Tim, I was thinking whether if we actually put some effort into describing those failures a little bit more exact, whether that could be used to train the artificial intelligence to make the prediction a little bit better. I don't know. If the test failed, you can restart it from the web UI. That's the test detail page all the time. So there is a restart button, and you can stop it when it's running by pressing the stop button, or you can just restart it when it's still running. Dealing with needles, so you add a missing needle using the needle editor that is part of the web UI. You can define the area. You see that the green area here, so it's the needle defined for the P button on the calculator. You can name it and check the name, or select the name. It's above this, not part of this. And in the upper right corner, you can change the match level, so you can make it less than 96 or more than 96. So it's good that if you don't want to deal with the needles elsewhere, so you can just write the test without the needles, and you can create the needles with the first run of the test by using the developer mode that could be also switched on in the web UI. I'm going to show it to you when the test runs. I am sometimes using the Needly application that I sort of wrote when I thought that one totally needs a needle editor that runs offline. And it's quite good nowadays because it can connect to a virtual machine. So when you develop a test and you make it manually, you try it manually in a virtual machine, so you could use the Needly application to take screenshots out of the virtual machine, and you can create the needles offline without having to run OpenQA. So you can save some time, because creating needles in OpenQA is a little bit little bit slow, let's say, and it starts to be tedious if there are lots of needles, because you need to open the test editor, you edit the needle, you save it, then you have to click on come back, then it waits for some time, then you continue the test and it accepts the needle and it fails with another one, and then you repeat the procedure. So when you feel like that, it's good to do this while developing the test, and then you load everything into OpenQA and you only fix what doesn't work. You can, okay, that's not important, but you could use the Chancery application, which is a very simple editor that I also wrote as a sort of exercise in Python. And this is good because it has pre-loaded test API routines, so you don't need to go through the test API, but you just select what you want and it will give you the snippet in it, so it can help. But once you know the routines, actually you don't need it anymore, because then you just type the routine and yeah. Okay. So integration with Fedora, of course, everything is based on Fedora, everything is supported in Fedora, everything is installable from Fedora. We use it on a daily basis, so the Fedora testing stack is up to date and should be working. We don't have breakdowns much because our procedures don't allow to merge something that has not been reviewed. And Adam is a strict reviewer, so his hawk eye will not let any problem pass into the production repository. So if you want to test something on Fedora using OpenQA, it's very easy to do so. And as I said, you can install it, you can set it up in 20 minutes. There are some sources here that you can follow. This is just for the sake of the recording, or I will upload the presentation on the SCAD. So then you can take it and you can see that there is the OpenQA documentation that is maintained by SUSE. Also the test API documentation. We have the Fedora OpenQA install guide that this talk is based upon. So when you open that link, you will have a step-by-step how to install it. And the OpenQA auto-inst repository that is used to hold the tests and hold the needles is on Pagure. Thank you for attention, but we still have not have the 90 minutes, I believe. So let me show you how the test really runs inside of the OpenQA. Yeah. So first, I need to show you the varlib OpenQA factory HDD directory where the images are placed. You can see that there are lots of images, lots of QCOW images starting with a number, and then disk workstation life ISO 64-bit.QCOW2. So remember the product flavor variables that were in the test suite definition. So this is the disk workstation life ISO 64-bit. That's the part. And each test will create its own image, and the number is the test number to which the image belongs, actually. When it's there, you could actually repeat the tests again and again and again because they have something they called an asset to start with. Once you delete the underlying image, you can't restart the test anymore. That happens to me on production where I could come back. I would like to come back a couple of days and try, but it's already deleted, so it doesn't work. But on the local machine, until you manually delete those assets, you can still repeat those tests. So you can see that there is the workstation.qcow2, which will be used as a starting image. It's a pre-installed image, so I don't need to do the installation test before, because we don't want to waste time on 15 minutes Fedora ISO installation. You can see that it's owned by Gecotest. Here you can make an exception. You can either make it worldwide readable also, that will work too. But I do it, I always change the permission to be Gecotest because I think it's cleaner that way, but here in this directory it's not that important. Okay, then I will go to cd openqa, where I have the run test script. You can see that there are lots of them, those commands commented out, and I can select what I need, and so it's easy to start it this way. I like it, sort of. And I am going to start. Well, I realized actually that it totally doesn't matter what is in the ISO variable if you use a QCOW image for the test.
Oh yeah, of course.
You could also leave it out in this case. So let's ignore the ISO variable. Its distri is Fedora, version is Rawhide, flavor is Flock, Arch is x86-64, build is calculator test, subvariant is workstation, and desktop is GNOME to make it safe. But I don't think we are going to need the GNOME or workstation variables because we are not installing stuff. So I will run it now. Now it tells me that one test started, or one test suite started, 0 failed. The ID number is 4158. It starts with 0, so you know how many tests I have run on this installation particularly. And the product ID is 152, that's not important. And now when I go to all tests, I can see the calculator test running. 0%, but the progress bar is a little bit slow and it changes in steps. When I click on it, I get the live stream of what the test is currently doing. So you can basically watch if it does what you want it to do. Here you can have the developer mode. So by clicking on it, you can switch it on and you confirm to control the test. And now here you have fail on mismatch as usual, which means if the needle is there, fail. And if you leave it like this, it's like with the development mode off. So you can still have it on, but it doesn't affect anything. When you change it to assert screen timeout, then any time a needle is not found, it will give you the opportunity to open the editor and created. So this is how you can create needles when the test runs. And we are not using it in our test, but sometimes you can use check screen instead of assert screen, which returns a true value if the needle has been found. And that's a specific thing, and you can also make the development mode control the check needles. The problem is, if the check needle, for example, is not there on purpose, and you switch it on, then it will complain and it will force you to create the needle. Once you forget that it's on purpose, not there, and you create it, then you will get some troubles later. So yeah. Now you see that the calculator the calculator test has ended in the meantime, and it has passed, which is great. On the detail page, I can see what the test actually was. Sometimes, if you forget to sync the repo, you might be testing old tests. I am not developing in the OpenQA repository because it's that requires everything to be typed with sudo. So I'm developing aside, and sometimes I forget to push or pull, and then it does the same thing that should have already been corrected. So you can check that the test is what it should be, because you have the test script here. You can see what steps were taken and what needles were compared. So for example, this one makes sure that the calculator has started and it's 100%, which is great. Sometimes when the GUI changes, so it might be 0%, and then you need to recreate the needles, then it checks for the button 5, again it's 100%, and so on and so on. You could see the variables that it uses to run the test. So sometimes when you have a Fedora stack running and the tests start failing in big numbers, then probably something is wrong with the variables. So you can compare the production variables and your own variables, and you can set the variables correctly, and then that works like magic, and suddenly the tests start working. You can also take a look on the autoinst log txt, which is very important for failures, because it basically tells you everything what happens during the test run. You can see that you have the blue line here, which basically is the graphical weight login starts here, and this is what happens. So it wanted to check for the needle must match login screen, and at first it didn't find it, it didn't find it, it didn't find it, and didn't find it. Then login screen timed out, and it wasn't found, but because it's check screen, so it was probably correct. Then it wanted to assert the screen, login screen, and then it sort of found it after 10 seconds approximately, and continued and continued. You could also use the DIAC routine to put or print out messages to this autoinst log txt file. So that might also be the way how you increase the readability of the log files if you need. You can leave comments here, of course. In production, you can put the bug number here, and then it shows that the bug has been already created. So on production, you might see that there are little bugs, symbols just below, or next to next to a failed test, and you know somebody has already created the bug, and yeah, that's it. Also, what is interesting, you get a nice video of the process, so you can.
I always imagine the yakety sax theme playing in my head while I watch it.
Yeah, it's quite fast, the video, but it can be slowed down a bit using the Firefox menu, and you can set the speed to 0.5. It still is quite fast in 0.5, but at least you can see. So you can stop it also, but then it's very difficult to find the correct place. But yeah, it can be helpful too. So I think this is it. And if you have questions, you can ask.
With all that talk about needles, I'm missing either a thread or a haystack. Or, to sum it up, why is it called needle?
I don't know, to be sincere. Maybe it's because of the haystack, maybe. Because it finds small portions of a picture in a big image. Maybe it's because of that.
You don't find a haystack.
Well, sometimes you do. There is a strategy how you might find a needle in a haystack.
Well, to carry on that analogy, usually it's you're looking for a needle in a haystack. So the haystack is given, the needle is given. So you do the searching. What do you use for that? A magnifying glass or whatever, or a magnet? But what you're doing here is you define the needle, which is put into the haystack, and then you check whether the needle is there. It's a weird terminology. I might.
The haystack, basically, as I understand it, is the PNG file. The needle is the little portion, and both are there. Just the one you expect might not be there.
But since you define the needle, you can make it as big as you like. It could be the entire picture.
True.
And then it's not a needle anymore, is it? Then it's a hammer or something more.
Okay. Okay. That's a very good point, which reminds me to tell you this. The size of the area actually matters, because the bigger it is, the more problematic it will be to find. And sometimes when you have a tiny pixel glitch in the image of the virtual machine, so it won't be found. If it's too big, you will, and you expect 96%, you will have troubles. So the best strategy is to keep the needles as small as possible. You can, if you need to check for more, you can define more areas inside of the one needle. But the smaller they are, the better for you. On the other hand, of course, I once experienced a case when I wanted to check whether the button was lit or not. So basically it looked the same, it just would be a little bit blacker or with darker shade when off and with a lighter shade when on, and the classical 96% wouldn't be able to cover that, because in both cases it would be above 96. So it wouldn't be able to differentiate between off and on, and I had to explicitly make it 100%, and only then it was able to distinguish between the states. Sometimes it's like it's a funny play with those needles.
It was my first comment was, of course, more like a joke and trying to get my question in there. I totally understand what it's doing, and it's very useful the way it works. It's just sometimes you ask yourself these questions like, how did they come up with that name, and why did they use that terminology? It doesn't make sense to me.
Well, it doesn't make sense to me how a chameleon could look at one side and another side at the same time, you know.
So, does this support accessibility testing?
Accessibility testing, like this, for example, or which accessibility do you mean?
So, the calculator test that you ran, if I do it on a high contrast or say a color change mode, can I reuse the test? Or
you can reuse the test, but you have to recreate the needles. So you could have basically a couple of sets of needles, and you could, for example, you could use the calculator test on high contrast, normal contrast, large text, you know, and it would work.
So this is interesting because this is why the needles have the tag concept. So you would have the exact same test logic, and you just have 3 different needles which have the same which all match on the same tag. So we use this a lot. We have lots of cases where we have, different needles that match on the same tag because of various conditions making the screen look different. So that's how you would do that.
And basically, just to add to Adam, if you run a test, the calculator test, and you have the needles to create, you have created the needles to support the high contrast, for example, or the normal contrast. So it doesn't matter actually which one of the tests will run. Both would pass because the needles are there already. So you don't have to tell it, use the high contrast needles. So if the test is high contrast and the needles are there along or next to the normal contrast needles, the test will pass okay.
I have a question about, let's say, the target audience for this. So who should be most interested to look into this? Let's say if I am a package manager, packager in Fedora, and I have some graphical application in Fedora, should I try to install this and create a test and submit it as a pull request for you, or is it targeted at me or not?
Well, I would like to say yes, but the question is, do we have space for it? Do we have resources for it? I believe if that's a single test, for example, a single application is tested, we would have resources to do it. If it's like 100 applications, maybe we don't have the resources because the time to run all the tests is sparse. And so basically, if you are a packager who develops a Fedora application that is part of the installation or heavily used in Fedora, and so then I think it's good to make a pull request and write a test, or make a pull request, and we could take it to our stack and test it, right?
Yeah, there are different directions someone could go with this. As Lucas says, if you want to get a test into the official repositories, before putting too much work into it, it's probably best to file an issue, and we can discuss whether that's a test that we would want to carry in the officials. But you can also just stand up your own OpenQA instance, as Lucas has explained, and use it. You can do this kind of permanently. I think there are cases of people doing that. There are other projects which have stood up OpenQA, like GNOME and Debian and stuff. So that's another way you could go with it. But yeah, we do have resource constraints on the official instance, so we have to kind of
I have, for example, talked to some Red Hat teams about OpenQA, and they said, oh, it looks great, but it's too complicated to maintain it. Well, actually, I don't think it's too complicated to maintain a local instance, because it works, it must work. It works for us all the time, so the basic thing is to install it and run it, that's it, you know. Nothing to maintain, because it's maintained by Adam.
It does take you your 20 minutes to get your initial instance running, but then after that, it'll kind of sit there and work. Like, you can have your pet instance sitting there and not use it for 6 months, and if you come back and update your system and try and run a test, it'll probably be okay.
Yeah.
It's not a lot of ongoing maintenance involved. It's
There
kind of
is-
initial setup. But once you've done it once and figured out how to write a test and add it into the templates, it all gets a lot less overwhelming. So it's a kind of a little bit of an initial setup and then a sort of plateau of...
And there is one problem that could actually arise after an upgrade. And that's the Postgres server, because sometimes it gets updated and you need to update the database running the specific command. If you don't do it, it won't start, and then OpenQA won't start. But it's probably pretty... Yeah, once or twice maybe, yeah. And, okay, one more
Okay,
question.
so if I understand correctly, I guess this is most interesting to some teams that could be working on some bigger projects, or some maintainers of some high-profile applications, for example, like LibreOffice or something, that would be interested to be pushed into the Fedora production instance, or perhaps some passionate maintainers that want to run their own local instance. Is it correct?
Or by anyone in the community who wants to help us creating the tests for Fedora Stack. Cool. Thank you very much.
Awesome. Thank you, everyone, so much. That concludes today. If you haven't already gotten your Flock badge, please scan the QR code in the back of the room. And otherwise, we'll pick up here tomorrow for day 3. Thank you all so much.